Hello everyone, welcome to our channel, and I, CS Fatema Kagalwala, I am going to take you all and we are going to study quantitative aptitude, which is a part of your CSEET portion. So quantitative aptitude, there are two chapters. I am going to teach those chapters to you all. We are going to have a marathon kind of a session wherein I am going to take you all through all the concepts which are there in these two chapters. It is for 20 marks. Okay, your quantitative aptitude itself is for 20 marks. Now this chapter, for your convenience, I have divided this chapter into 3 parts. Okay, so basically I have taken it up in 3 parts. Okay, all the 3 parts, the notes and the videos are there separately. You all can go ahead and refer to the notes of that particular video. Okay, so starting with today's lecture, today's first part in quantitative aptitude in number systems. Number systems is your chapter. So now basically when I'm talking about number systems, we all know what is number systems. Like we know 1, 2, 3, we know all our numbers, infinite numbers. Okay, so in number systems, this is the introductory part. Okay, now basically in a number system we have it is a unit. Okay, so it is a unit of basic unit of mathematics. For counting we use it as a measuring and for comparing the amounts. Okay, so it is for arithmetic calculations for which we have these number systems. Okay, so you can say it is a set of symbols, numericals, etc. Now there are types of numbers. We have various types of numbers. So this chapter is basically about all these types which we are going to cover in this part. Okay, so this first part will cover all these 6 types, starting from natural numbers. Then we have whole numbers. We will see what are integers, rational and irrational numbers, and then coming to the real numbers. So your part 1 will consist of all these 6 topics. So coming to just one small chart which I have kept here for you all, that when I am talking about number and its types, so these basic numbers which I just spoke to you all, which we have natural, whole numbers, integers, we have fractions. So I have given you all example. So when I am talking about natural numbers, I am talking about numbers starting from 1. So 1, 2, 3, 4, 5, 6, 7, those are my natural numbers. Whole numbers is a number because 0 is included in that. From 0 we start the counting, so it is whole numbers. Then we have integers, those numbers which we can represent on the number line. Then we have fractions. Okay, we have rational numbers. I will teach all that in depth. Okay, each set of types of numbers. Irrational numbers. Then we have real numbers, some numbers which are imaginary, prime numbers, and composite numbers. Okay, so let's see each number type. Okay, now see this. When I am talking about natural numbers, I am talking about all the numbers which are on my right hand side of the number line. That is 1, 2, 3, 4, all those numbers, these numbers. Okay, so 1, 2, 3, 4, 5, all these are my natural numbers. Okay, whole numbers is because it begins with 0, so even they are on from 0 and then again going to the right hand side, those will be my whole numbers. And integers is both. Integers is nothing but natural numbers, okay, natural numbers and whole numbers. Okay, natural numbers, whole numbers, and even these numbers which are there on the left hand side, okay, of the number line, the ones which are denoted in the negative sign, they are also integers. Now whenever there is a number which is on the right hand side of the number line, will always have a greater value. This we all know, right? Whenever there is a number which is on the right hand side of my number line, it will be of a greater value. So if I say A is placed on the right of the B, so A will be greater. And if A is placed on the left side of the B, then A will be less, B will be greater, right? Because on the right hand side we have positive numbers. Positive numbers are greater than the negative numbers. Clear? Okay. Then one second. Okay. So just again the description, when I'm talking about natural numbers, I'm talking about all the counting numbers which begin from 1 till infinity. When I talk about whole numbers, it is nothing but all the natural numbers which are there, but which is starting here, it will be, there is 0, including a 0. All the counting numbers which is including a 0. These are commonly called positive or non-negative integers. Why? Because they start from 0, then 1, 2, 3, 4. So they are positive. Integers, they consist of all the natural numbers. They consist of a 0 and they consist of the inverse. Inverse means the negative numbers. Okay, so all the numbers on the number line, like how we just saw the image. Then we have rational numbers. Okay, now what are rational numbers? All the numbers that can be expressed as a ratio. Rational means ratio. Okay, it is derived from that word. Between two natural numbers, any natural numbers, then it is known as the rational numbers. So there has to be a relationship. Okay, so it is 2 upon 3. Both are natural, 2 and 3, both natural numbers. Okay, they are given in the form of fraction, therefore they are known as rational numbers. Non-terminating decimal numbers with infinitely repeating patterns are also rational numbers. There can be certain decimal numbers like say example 0. Okay, it is 0.3333. Okay, they are repeating patterns. Okay, infinite, non-terminating. The decimal point is not terminating only. You don't know where it is going to terminate. Okay, so they are also known as rational numbers. Irrational numbers, they are those numbers, they cannot be written as fractions also. They cannot be written as a ratio also. So they cannot be written by this form. Okay, examples will be like square root of 2. Okay, non-terminating and non-repeating decimals. They have non-repeating decimal patterns. If you see this 0, 0.10, 100, 1000. So pi, all these are irrational numbers. And when I talk about real numbers, all these numbers which we just spoke about all belong to the set of real numbers. So in real numbers, we have natural, whole, we have irrational, we have rational, integers, everything this belongs to the real numbers. Okay, so you will see this, I have made one chart for you all. So in real numbers, you have rational numbers, you also have irrational numbers, and in rational numbers, in the rational numbers, there are also integers. Then there we also have the whole numbers and there is natural numbers also. Okay, so all this are part of real numbers. And then we have irrational numbers like a square root of 10, pi, square root of 3, square root of 2. Okay, these are irrational. There is no finite, there is no pattern of the decimals also over here. Alright, so they are irrational. Now coming to types of numbers, each type of number with certain MCQs. Okay, because this is an MCQ exam, so they will ask you a few questions which are there from each of the chapters. Okay, so I have given you all MCQ for each type. So coming to again natural numbers, we are saying what are natural numbers are nothing but they are positive integers. They are known as positive integers. They begin from 1, 2, 3 till infinite. If I will add these positive integers, also I am going to get another natural number. If I will subtract also, I am going to get a natural number. There can be cases where I will not get a natural number. Okay, there can be some cases where I will not get a natural number. Now see, let's see. Example, if I do 2 plus 3. Okay, 2 plus 3 is 5. It is a natural number. 2 into 3 is 6. Both again natural numbers. So addition, multiplication of natural numbers will give a natural number. But subtraction and division can give a, not necessary it will give a natural number. Okay. It may or may not give you a natural number. Now how? See. If I am subtracting 5 from 7, 2 is a natural number. But if I do the reverse, if I am subtracting a smaller number from the greater number, I am going to get minus 2. Minus 2 is not a natural number, but it is an integer. It is an integer. Okay. Yeah. Also, if I am subtracting the same number by itself, a number by itself, I will get 0. 0 is not a natural number, it is a whole number. Right? If I am dividing, 8 divided by 2, 4. 4 is a natural number. But if I am dividing 7 by 2, I am going to get 3.5. 3.5 is not a natural number. Okay, it is a rational number. It can be denoted in fraction. Okay, so in case of natural number, I can say there is no greatest natural number. Now there are certain MCQs on natural numbers. Let us see. Which of the following is not a natural number? Okay, so very easy to solve. Which of the following is not a natural number? You all would like to answer? You all can also answer. Which is not a natural number? 0, no? It's there already. So 0, because others are all natural numbers. 0 is not a natural number. Answer is 0. What is the sum of the first two natural numbers? Now what is the first two natural numbers? We have first natural number is 1. Second natural number is 2. They are asking me the sum. So it is going to be 3. If you multiply two natural numbers, will the result be always a natural number? Yes. Addition and multiplication, always it will give you a natural number. Subtraction and division may or may not give you a natural number. So answer is yes. Okay. I am moving to the next question. What is the product of 3 and 4? When they ask you product means they are asking you to multiply. Okay, multiply. So product of 3 and 4 means 3 into 4. The answer is 12. Some simple questions like this they are going to ask. So you don't have to like kind of worry what is there in quantitative aptitude. How are we going to study? You can study with me and finish up this chapter. Okay. Which of the following operations on natural numbers does not always result in natural number? I just spoke about it. Addition of two natural numbers will give natural number. Subtraction of two natural numbers may or may not give. So this is the answer. Multiplication will always give. None of the above is not the answer. Right? Okay. Now I am moving to the next type of the number, which is whole numbers. So it is basically the natural numbers, but it begins from 0 now. 0. What will happen if I am adding 0 to any number? I will get the result of the number itself. So 5 plus 0 will give me another natural number. Okay, 4 plus 0 is 4. 4 into 3 is 12. Okay, so when you add or multiply any two whole numbers, the result is always another whole number. So say suppose I am multiplying 4 into 0. What it will happen? 0. Answer is 0. If you multiply 0 with any number, it becomes 0. 0 is a whole number. Yes. When I am doing addition also, I 5 plus 0. I did an addition. 5 is again a whole number also. It's a natural number as well as a whole number. And there is no greatest whole numbers. Whole numbers means whole numbers. It does not include fractions, negative numbers, decimals. No. Natural numbers are also, they don't include all these fractions, ratio, negative, nothing. Okay. Let's see, there are certain properties of 0. When you add a 0 to a number, the answer will be the number itself. When you subtract, so when I am doing a minus 0, I will get a. But 0 minus a, I will get minus a. Minus a is not a whole number. It's not a natural number. It is an integer. Okay. Multiplication, I will always get 0. If I am multiplying 0 with any number, it always be a 0. So 0 is a whole number. Division. 0 divided by any number. 0 divided by any number, it's always a 0. Okay, division by a 0, we don't know only. Division by a 0 is not defined. So if I'm defining 2 divided by 0, there is nothing like an answer. There is no division by 0 ever happened. Okay. 0 is the only whole number. Only one whole number, 0. 0 is not a natural number. 0 is not a natural number. Very, very important. 0 has no positive, no negative sign. Okay. Predecessor of a 0 in whole number. Since 0 is the smallest whole number, it does not have a predecessor. Okay. It does not have any number preceding in the set of the whole numbers. There is no whole number that comes immediately before 0. So there is no whole. There is an integer minus 1 which will come before 0. But there is no whole number which comes before 0. Okay. Clear anyone? Anybody? Any doubt? Any question? Whole numbers. Okay. And natural numbers. Important MCQ for whole numbers. Okay. Now which is the smallest whole number? 0. If I'll do 5 plus 0, the answer will be 5. If I'm multiplying any two whole numbers, answer will always be a whole number? Yes. Okay, if I'm multiplying any two whole numbers, answer will be a whole number. Okay, so 5 into 0, I'll get 0. 0 is a whole number. Which of the following is a whole number? Only 0. What is 7 minus 7? 0. Again, 0 is a whole number. Next is integers. Okay, so I am finished with natural and whole numbers. Third is integers. Integers is nothing but on the number line we plot negative numbers also. So those negative numbers and 0 and all the other positive numbers, natural numbers, they all together are known as integers. Okay. So now what are the properties of integers? Addition, subtraction, multiplication, division, whatever. Okay. When you add, subtract or multiply any two integers, the result will always be another integer, obviously. If I am adding minus 5, okay, if I am doing minus 5 plus 2, negative and positive, if there is a minus and plus sign, you will always subtract and the sign will be of the greater number, always. We all know that. So whenever I do addition, subtraction or multiplication of two integers, the result will always be another integer. See this, 2 minus 7 is equal to minus 5. Minus 2 into 3, whenever I am doing multiplication of a negative and a positive number, multiplication will come but the sign will always be minus. Okay, so 12 minus 33, 0, all are integers, but any fractions and decimals, they are not integers. Okay, so this you all have to remember. For MCQ point of view, you have to remember the conclusion and their properties. Okay, so you have to remember this, all these conclusions and the properties of each type of numbers. Let's see some important questions on integers. Which of the following is an integer? 1.5, not an integer. 2 upon 3, not an, this square root of 2 is all, minus 3 is an integer. Okay, so minus 3 integer. It can be represented on the number line. What is the result of minus 5 and plus 7? I told you if there is a negative and positive number, subtract sign of the greater number. So sign will be of 7. So it will be plus 2. Okay. Then you have, if you multiply two integers, the result will always be another integer. Yes, it will be. This is the properties. What is minus 3 minus minus 2? Now, this is what we have learnt in school. Whenever we open the bracket, the sign will change. Minus and minus will become plus. Now, there is 1 minus and 1 plus. I will subtract. I'll get answer 1 and sign of the greater number. So, the answer is minus. Don't make silly mistakes in this, okay, when you are giving your paper, because this is something wherein you are going to get 1 full mark for something like this. Okay. Which of the following is not an integer? 2.5. Rest all are integers. Positive number, 0, negative number, all are integers. Clear? Up till here? Anybody has any doubt, any question you all want to ask? Then I'll move to rational numbers.
I don't have any.
No? Okay. Good. Sure. So now rational numbers. As I told you, this is the word which is originated from the word ratio. So those numbers which can be represented in form of ratio or a fraction, I will say it is a rational number. So rational number is any number that can be written as a fraction. So there is a number in the numerator and there is a number in the denominator, and these numbers can be integers. Okay. Now, where both the numerator, the top number, and the denominator, that is the bottom number, are integers, and one condition, that the denominator is not equal to 0. Okay. Numbers that can be expressed as a ratio of two integers, where what is that? P upon Q, where Q should not be 0. This is the condition of a rational number. So see this. P upon Q, P is an integer. Say Q is also an integer, but a non-zero integer. Non-zero integer. It can be negative, can be positive, but it should not be a 0. That will be known as a rational number. So these charts, this make it very easy. These type of images make it very easy to understand. So now let's see the properties. So they include fractions and terminating and repeating decimals. Okay, so whenever the fraction, the decimals will be a terminating decimal or it will be a repeating pattern of the decimal. So when I am saying 3 divided by 4, if I am literally dividing 3 by 4, I will get this answer 0.75. Okay, so this is going to be a rational number. If a number can be expressed as a fraction where both numerator and denominator are integers, the number is a rational number. So if I say 56, can I write 56 like this also? 56 upon 1, which is another form of 0 is what? 0 is nothing but 0 upon 1. Okay, then you have 1 upon 2. You have square root of 16, which is equal to 4. Right? So, then minus 3 upon 4. When if I am saying 0.3, means it is 3 upon 10. If I am saying 0.03, I will say it is 3 upon 100. Yeah, I can represent it in the form of decimal also or in form of fraction also. Right? If there is a minus sign, I'll put a minus sign. Okay. Now, what are the properties under addition, subtraction, multiplication and division? Division, 0 should not be there for a rational number. Okay. When you perform these operations on any two rational number, the result will always give you another rational number. So, now let's solve this. Okay. We will just solve these examples. Come on. 1 divided by 2. I am doing addition of two rational numbers. Okay, whenever I do addition and the denominator is not same, what I will have to do? I will have to multiply this. I have to make the denominator same. Multiply this by 3 and multiply this numerator also. So this side by 3 and this side by 2. So I'll get 3 plus 2 upon 6. That will give me 5 upon 6 as an answer. Okay, 5 upon 6. Same thing here. 3 upon 4 minus 1 upon 2. I'll have to make the denominator same. So how will I make the denominator same? I'll multiply this 2 by 2, no? So it will become 4. So it will be 3 minus 2 upon 4. So it will be 1 by 4. Answer. Multiplication of two rational numbers is little different. It is very simple. 2 upon 3 into 3 upon 4. So basically you can just multiply. It will be 6 upon 12. Or if you have this common, 1 in numerator, 1 in denominator, this will become 1. So it is basically 2 upon 4. I have to make it in more simpler form. So I will say 2. 1s are 2, 2s are 4. So it will be 1 upon 2. Right? And when am I doing division of two rational numbers? This will come in the next part also. So remember, 3 upon 4 divide by 1 upon 2. Whenever there is a division, change this division into multiplication. How will I do that? Simple. I will say 3 upon 4 into 2 upon 1. The moment I change the sign, I will do the reverse, inverse. Instead of 1 upon 2, I will do 2 upon 1. So this is going to become, you can say 6 upon 4. You want to make it in more simplified form, so it can be divided by 2. So 2 3s are 2 2s are. So 3 upon 2. Answer should be right. You all are not allowed to use calci. So you all have to solve. Pen and paper. Okay. Then they have terminating and repeating decimals as rational numbers. So whenever they are into decimals also, they have a terminating decimal. They are not infinity decimals. Okay. And if they have a repeating pattern also, then also they will be a rational number. Okay. However, see, terminating decimal numbers which end at a certain point, they are rational. Even non-terminating decimal numbers, but they are having some repeating patterns. They are not able to get terminated, but they have a repeated pattern in the decimals. Then they are also rational. Okay, one is terminating, they are the rational only. But if they are having a repeating pattern, okay, repetitively same pattern is coming, like 0.3333, it might just go on. Okay, or I can say 0.141414. Okay, it might not terminate, but they have the same pattern. Okay, why are they rational numbers? Because they can be converted into fractions. Very important. Conclusion. Clear here? Okay. So terminating decimal numbers are something which they can be terminated at a given point of time. So 0.5 terminating, it is over, the number is over. 0.5 means half, 1 divided by 2. Okay, even longer terminating decimal numbers, they can be easily converted into fractions. So say if I am writing 0.0001, so basically it is nothing, it can be expressed as 1 upon 10,000. Put this number of zeros after the decimal. So there will be 1, 2, 3, 4. The number of places after the decimal, that many number of zeros you will put. So it is a rational number. Right? Non-terminating decimal numbers and infinitely repeating patterns. Okay. So they might not terminate, but they can have a repeating. See, I just gave you all this example, 0.333. See? This, yeah, you can write it in, we generally then round it off and we write it only up to 2 decimal places. So 0.33. Okay, this can be converted into fraction, that is 1 upon 3. Okay, but there are certain complicated numbers like 0.14287, 2857, then again 142857. Okay, so this 142857 keeps repeating. Okay, but they can be converted into decimal number. When you convert that, no, it will come as 1 divided by 7. So therefore it is a rational number. So any terminating number, decimal number, is a rational number. If it is not terminating but having the same series or pattern, repeating patterns in decimals, again it is a rational number. Why? Because they can be converted into fractions. Okay. However, there are certain decimal numbers that go on infinitely and they do not contain any repeating patterns. Then they are not rational numbers, but they are irrational numbers. This is important. Okay, they are irrational numbers. Let's see some positive and negative rational numbers. Okay, rational numbers are always of two types. Okay, positive rational number is where both the numbers are positive integers. Okay, or if both the numbers are negative integers, both the signs are same, then they will be known as positive rational numbers. So say if I am having -5, okay, and -7, both the numbers are minus minus, so it is a positive rational number. Minus and minus sign gets cancelled. Positive rational number. I have 3 and 4. Plus 3, it is plus 4, minus sign is not put. Again, this is a positive rational number. So with the same signs, both the integers have the same sign, it is a positive rational number. But if they have different sign, if one number is positive, one number is negative, it will always be known as negative rational numbers. So if I am saying -1 upon 2, one is positive sign, one is negative sign, it is a negative rational number. Similarly, -12 upon 4, 16 upon -3. Any number, either in numerator or denominator, if any number is minus and other number is positive, it will be a negative rational number. Okay. Now let's see. Some examples are there. Classify natural numbers, whole numbers and integers. Okay. So if I'll classify natural and whole, rest all will be, they both will be together known as integers only, no? Okay, the minus sign we will include in the integers. So if I want to say natural numbers, 22 is a natural number, 7 is a natural number, 0 is a whole number, 12 is a natural number, and 13 is a natural number. So 7, 12, 13, 15 and 22. This 7, 12, 13, 15, 22 will even stay in the whole numbers, but 0 will be added. Okay. And now if I want whole numbers, now I want to see the integers also. So all of them are integers. All of them are integers. Okay. All the natural numbers are whole numbers and integers, but vice versa is not true. Whole numbers are integers also. Okay. Now say this. Simplify the following. Indicate whether or not the outcome is an integer. Okay, so we have to solve this and say whether the outcome is an integer or not an integer. So if I am doing 12 into 4, 48. 48 is an integer. 7 divided by 3. 7 division by 3, I will get it in the form of decimal points. Therefore, it is not an integer. 18 divided by 3. 18 goes in the table of 3, no? 6. 6 is an integer. 36 divided by 7. It will go, answer will come in points form. Therefore, not an integer. It is a rational number. 14 into 2, 28, integer. 18 divided by 6, again it can be expressed in form of fraction or a decimal. Therefore it is not an integer, but it is a rational number. You can say it is a rational number. Okay. Now certain important MCQs for rational numbers. Which of the following is a rational number? Square root of 2? No. Pi is also no. 0.75, this can be written into a fraction. In decimals it is written, no. So, and terminating decimal. 0.75 rational number. E is not a number. What is the result of 1 upon 2 plus 1 upon 4? This we have solved. You have to make the denominator same in case of addition. So 2 plus 1 divided by 4. It will be 3 upon 4. Now converting 0.125 into a fraction. Now how will I do that? If I want to convert 0.12 into 125 into a fraction, I will say 125. I want to remove this decimal. Divide by 100. Okay. So this is going, I have to convert this into a fraction. So 125 divided by 100 I can do. And then in that I have to also again multiply this by, yeah, this I have to multiply that again by 100, and here it will be this I will have to do 100 over here. Okay, and here it will be 125, divide that by 100 into 100, that will be like 10,000. Okay, so 125 ones are 125 8 is a. Okay, that will give me, because I am keeping over here as 100, so here also I will have to now multiply this by 100. Okay, 1 upon 100 I can do. Means this is 125 into 1 will be 125. And since I have converted this decimal into a fraction, okay, to convert that I have to take 1, 2, 3. So 100 places. Okay. So that I have taken it. So it will be 10,000. So 125 ones are and it will be 8. And 1 divided by 8. Answer will be 1 divided by 8. Okay. Which of the following fraction is equivalent to 0.5 is basically nothing but half. So half is nothing but 1 upon 2. Okay, so where solving is not required, don't solve, directly give the answer. Which of the following decimals is a repeating decimal? Repeating. It's not terminating. So 0.25 terminated, 75, 1.5 terminated. This is repeating. Same pattern. Okay, so 0.3333. So again, just one small quick recap: rational numbers and irrational numbers. Irrational numbers are these some numbers: square root of 5, minus square root of 2, pi, minus square root of 6. Okay, they are like infinitely non-repetitive decimals will come. But in real numbers, we have rational, we have integers, we have whole numbers, and we have natural numbers. Okay. Now irrational numbers. So non-terminating, non-repeating decimals. So you see number pi is an irrational number. Why? Because it is expressed in the form of 3.1415. Nothing is there as repeating decimal. Square root of 2. If you will do sometimes in calci, square root of 2, you will get this answer. Irrational number. Okay. So properties: irrational numbers, they do not terminate and they don't even repeat themselves. Okay, the sum or product of two irrational number is not necessarily irrational. So now let's see, certain examples are there. Which of the following is a irrational numbers? MCQ examples. 4.5 is a rational. It can be expressed in fraction. 0.333 is also rational. 5 is a natural number itself, rational also. And square root of 3 is a irrational number. What is the value of pi in 2 decimal places? 3.14. This you can by heart it. Which of the following number has non-repeating, non-terminating decimal number? Of course, square root of 5. Which of the following numbers cannot be written as a fraction? Square root of 2. Same, all this is same only. The decimal expression of an irrational number will be terminating? No. If it would be terminating, it would be a rational number. Repeating? No. Non-repeating and non-terminating. Answer is 3. Okay. Then coming to the real numbers. Real numbers, both. Rational and irrational numbers, both. Okay, every point on the number line corresponds to a real number. 0, 1, negative numbers, square root, fraction, pi, everything can be placed on the number line. All the possible magnitudes. Okay, so rational, irrational, both are real numbers. Okay, so what are the certain MCQs I have taken for real numbers? Nothing is there now to know in real numbers because we have already done all the types. So which of the following is a real number? See, square root 3 by 4, it will be a real number. This will not be a -1. This cannot be represented. 1 plus I, what? Minus square root of 2, nothing. The only first 3 upon 4 is a real number. What type of number is square root of 2? It is an irrational number. Okay. Which of the following can be represented on the number line? I minus I, all that cannot be represented. Even there is I over here. Square root of 3 can be. Which of the following sets includes both rational as well as irrational real numbers? Okay. So real numbers is both rational as well as irrational. Which of the following is not a real number amongst this I thing? Anywhere there is a number along with a alphabet, not a real number. Okay. Now there are certain numbers which are very complex and imaginary. Okay. If one category of a number is a real number, then other is complex and imaginary numbers. Complex numbers are numbers that have a real part and an imaginary part. Okay, so real numbers we have both rational, irrational numbers. Now let's see what is imaginary. Okay, so it's still loading.
Ma'am?
Yes?
A doubt.
Yeah,
Shall I
tell.
use calcium for exams?
No, you cannot use calcium for exams.
Can we use pen and paper then, ma'am?
Yeah, pen and paper is allowed. Pen and paper is allowed. But that also I will let you know, it depends on whatever is the instructions coming. Don't worry, you will not get such complex things, okay? Very basic ones. It's only for 20 marks. Okay. Now you have prime numbers and composite numbers. Just a minute. Prime numbers and composite numbers. Now what is prime numbers? Prime number is a natural number which is greater than 1 always and has exactly two divisors. One is number 1 and other its number itself. Otherwise it cannot be divided by any other number. So number 1 is not a prime number also and it is not a composite number also. It is a natural number. 0 is also not a prime and not a composite number. Any number which is greater than 1 and has only two divisors. Okay, only two divisors. Then it is a prime number. Prime number. We all have done this in school. Okay. So only the number 2 is the smallest of that. Number 2 has only two divisors. It can be divided by 1. It can be divided by the number itself. 2. Okay, so examples of prime numbers are 2, 3, 5. 5 does not go in any other table but in the 5's table. 5 ones are. Right? So 5 and 1. 7, 11, 13, 17, 19. Okay, so these numbers are known as prime numbers. So there are certain examples of prime numbers, MCQs. Which of the following is a prime number? 4, 6, 15. They have more divisors than 2. 2 twos are 4, right? So 2, 1, 4, all are the divisors of 4. 2, 1, 4, more than 2 divisors. 6 also it can go in 2, 3, 6, 1, right? 15 as well. 11 is a prime number. Which of the following is a composite number? And these numbers which are not prime numbers, they are composite numbers. Okay, 0 and 1. 0 and 1, they both are neither prime nor they are composite. Okay, this you have to remember. 9 is a composite number. Which of the following is neither a prime nor a composite? I just said 1. What is 0 classified as? Prime, composite, neither? Neither. Okay. Now rounding up the numbers. How do you do the roundup of the decimals or any number? So rounding off to the nearest whole number is important. So if any decimals, say if I am saying 7.3, okay, so if it is 4, okay, it is less than 4 and less than 4, okay, up till 4 I will say, up till 4, the decimal point up till 4, then round it off to lower, come down 7. But if it is more, 5 and more, say this, then round it up to a higher number. Okay, so when the decimal number is less than 0.5, less than 0.5, the whole number can be a number below the output. But if it is 0.5 and above, 0.5 and above, then it can be a number above the product. Okay, the next whole number. So you can say 3.5, you can round it up to 4. 3.6, you can round it up to 4. But if it's 3.4, you will round it up to 3. Okay. Then, okay. Every natural number is a rational number. These are certain other important conclusions. Every natural number is a rational number. But every rational number is not necessarily a natural number. No, because natural numbers are positive integers. 1, 2, 3, 4. Rational numbers can be expressed in the fraction. So natural number can be is a rational number also. It can be written like this. A natural number 3 can be written like 3 upon 1. 3 upon 1 is a rational number. But every rational number, this is not a natural number. So these are the important conclusions, summaries. Every whole number and integers are rational numbers, but vice versa is not true. So say whole number is a non-negative integer starting from 0, and integers include all positive and negative whole numbers. A natural number is nothing but that can be expressed as a fraction. Okay, now there are certain example questions. I will solve 1, 2 and then rest you all can do. It's not very difficult. Chalo. This I have solved also over here. A number in which 1/5 part is increased by 20 is equal to 1/20 part is increased by 30. Find the number. So let the number be x. I will explain you the question. Let the number be x. They are saying a number in which 1/5 part of its number, 1/5 part of the number increased by 20 is equal to 1/10 part of that number increased by 30. So this is the equation, right? So x upon 5, okay, x upon 5 plus 20 will be equal to x upon 10 plus 30. Now you have to solve this. You can say x upon 5 minus x upon 10. This will be equal to 20. I am taking the 30. This 20 I am taking on the other side. So it will be minus 20. I got this x upon 10 on this side. So it became minus. No. Now I have to make the denominator same. So this will become 2x minus x upon 10. This will be 30 minus 20, 10. 2x minus x will be 1x. This 10 I am going to take it on the opposite side. So 10 into 10. So this answer will be 100. Understood? You all know how to solve this, no? Whenever we take any number on the other sides of the equal to sign, their signs will change. Right? Multiplication will become division, division will become multiplication, addition will become subtraction, subtraction will become addition. Okay? See, the product of two numbers is 150 and the sum of squares of the numbers is 325. Find the sum of both the numbers. Okay, so let the two numbers be P and Q. They are saying the product of these two, P into Q is 150, equation 1. And the sum of squares of these two numbers, P square plus Q square is 325. So this is equation 1, this is equation 2. Now we know something like this. So A plus B the whole square is nothing but A square plus B square plus 2AB. Okay. So when I will find this, I will put all the values in this. A square plus B square. I know this. It is 325. P square plus Q square is 325. They have given me. 2PQ I can find. No, PQ I know 150. So 2 into 150, 300. So P plus Q, the whole square, I am getting it as 625. When I want to remove the square here, I will have to put a square root over here. So P plus Q will become square root of 625 is nothing but 25. 25 into 25 is 625. When I want to remove the square from this equal to sign, here I will have to put a square root. Okay. Next is which is the largest 4-digit number which is divisible by 91. Okay, so there are three numbers they have given. None of these we will see. Largest 4-digit number divisible by 91. So simple I did. 91 into what I will do, I will get like I have to divide that by 91. No, so 91 into something I have to do where I will get these answers. So if I do 91 into okay, divide this 9919 first. Okay, so 91 ones are 91. 80 9 minus 1 is 8. Carry this 1 over here. Okay, so here I will put a 0. Yes, 91. So 8 I cannot divide by 91, so I put a 0 and carry down the 1. 81. So now 91 by 9 will be 9 nines are no, 1 minute. Sorry, this is going wrong. The highest 4-digit number which is divisible by 91. So here it will be 91 9919. Okay. So 91 ones are 91. Okay. 8 will come over here. Okay. Here I will have to put a 0. I will have to bring 1 down over here. Now 91, it cannot even go in this 0. So I have to bring my 19 only down. Now I'll have to multiply 91 by 9 and see. So 9 ones are 9, 9 nines are 81. So 109. Okay, so 91. If I am dividing by this, if I am multiplying by 109, yes, I will get this answer. So this is one number. This will not go because last is 0. This will also not go. This is not the largest. This is the largest. No? So you use the the elimination kind of an MCQ. This is none of these. You leave that answer. 9900 will definitely not be divisible by 91. So I can try 9919 and then 9909. So let me try with 9919. Why? Because this is the highest number among these two. So yes, when I multiply 91 by 109, I will get 9919. So this is the largest 4-digit number divisible by 9. But you may not get such kind of questions. But yes, even if you get, you can do this. These are simple ones where you can multiply and divide on a paper. Which is the smallest whole number? 0. There is no predecessor for a whole number. What is the predecessor for a whole number? Whole number 0 has no predecessor. Okay, so these are all the questions which are there from this part 1. Okay, any questions, any doubts you all have in this chapter? Means this is the part 1. Okay, the types of numbers. Okay, so if I am saying this, 1 minute. So in number systems, this first chapter, types of numbers, is done. Okay, all these numbers: natural, whole, integers, rational, irrational, and real numbers. Okay, so this is what we completed in this first part. So with this, the first part gets over. Okay, everyone. Thank you.
Thank you.
Okay, so now we are going to start with the part 2 of our number systems chapter, quantitative aptitude. Okay, so this is part 2. Part 2, chapter 1, number systems. Okay, so this is one very easy part, decimals and fractions, how to convert a decimal into a fraction and fraction into a decimal. Not very, very difficult. So I have kind of made this a separate topic only. Okay, it is easy also, and few MCQs we will solve in this as well. Okay, so a fraction is nothing but it is a part of a whole. So if I am saying like we have a pizza and we cut that pizza into 8 equal parts and we eat 4 and 4 is left. Okay, so 4 by, like I have 8, I have eaten 4. Okay, so 1 by 2. Simplest form, that means half. Half is eaten, half is left. If I eat 3 slices, I'll say 3 by 8. 2 slices, 2 by 8. Okay, so it is just a fraction is nothing but a part of the whole of the object. Right? So fractions are 3 types. One is a proper fraction, one is an improper fraction, and one is a mixed fraction. Now when I say proper, means the numerator is always lesser than the denominator. It's a proper fraction. But if the denominator is smaller, okay, and the numerator is of a higher value, it is known as a improper fraction. And mixed fraction is nothing but it consists of one whole number, okay, this is the whole number, and one proper fraction. Okay, so these are the types of fractions. Now how to convert? If I am saying that convert an improper fraction to a mixed fraction, then what am I supposed to do? And from a mixed fraction, convert it to a improper fraction. How to do the conversion? Now say this. This is an improper fraction. Numerator is of a higher value than the denominator, 14 divided by 3. Simple. What I will do is, I will divide 14 by 3. 3 4s are 12. I will get one remainder, one quotient, right? And the divisor. So the quotient, the answer, the quotient, this answer is always that whole number in case of mixed fraction. Divisor will always remain 3. Divisor will never change. And the remainder will go as the numerator. Okay, so this is how we convert an improper fraction into a mixed fraction, where the quotient which we get over here becomes the proper whole number, whole 4. 2 divided by 3. Okay. Improper fraction into a mixed fraction. Again, one example I have given. If I am saying 7 by 3. So, simple divide this 7 by 3. 3 2s are 6. So, 2 is the quotient, that will become the whole number. 1 is the remainder, will go in the numerator. 3 will never change. It will always stay as a divisor. Okay. Then, conversion of improper fraction into mixed fraction. Again, one example. So, this is like you can just keep on reading through. You can solve it also. Now, what is simplification? Whenever there is a fraction, you simplify that to the simplest form. Okay. So, if I am saying 8 by 24, it is divisible, no, by 2. 8 is also divisible by 2. 24 is also divisible by 2. In fact, directly 8 is divisible by 3. 24 is divisible by 8. 8 ones are, 8 threes are. So, I can directly get 8 by 24 if I am saying, I know 8 is divisible, 24 is divisible by 8. 8 ones are, 8 threes are. So, 1 upon 3, this will be the simplest form of that fraction. Fraction with no common factors between numerator and denominator except 1 in its simplest form. There is no common factor. Okay. So, in its simplest form is important. So, equivalent fractions can be obtained by multiplying or dividing the numerator and the denominator by that same non-zero number. So, see, 8 and 24. I have divided that by 2. So, I got both numerator also by 2, denominator also by 2. So, 4 by 12. Again, I want to simplify it. Again, I did divide by 2. Again, I wanted to simplify. Again, I did divide by 2. Simplest form came where there is no common numbers in numerator and denominator. Okay. Now, see this. Greatest common factor. 8 divided by 12. Both, they will go in the table of 4. Right. So, if I divide 8 by 4, I will get 2. If I will divide 12 by 4, I will get 3. So, 2 by 3 simplest form. This also we have, you will always know how to do it in the simplest form. You are supposed to use the table properties. Okay, simplify the fraction. 24 upon 16. Take the number in which both these numbers are a factor. Okay, so 24 as well as the 16. 4. I can divide 24 also by 4 and 16 also by 4. If I will divide 24 by 4, I will get answer 6. And here I will get answer 4. Now 6 and 4 can be divisible by 2. 2 threes are 6. 2 twos are 4. So 3 upon 2 will be the simplest form. Now they cannot be further divided in the simplest form, reduced to simplest form. So operations. Like fractions mean what? If I say like fractions, 2 upon 3, 1 upon 3. They are like fractions. Where the denominators are always same. Always same. Different denominators are known as unlike fractions. Converting unlike fractions into like fractions for comparison is important. Okay, because addition, subtraction, etc. only you can do if you convert the unlike fractions into a like fractions. Now see this. These are like 5 upon 2, 2 upon 3 like fractions. So directly I will just do 5 plus 2, 7. Divide by 3. It became very easy for me to add, because both the denominators are same. Right? But if the denominator is not same, I will have to make it same. How will I make it same? 6. This 3 I can make 6, no? 3 twos are 6. So even the numerator I will have to multiply it. So simple, I will get 5 plus 7 twos are 14 upon 6. It will be 19 upon 6. 19 is a prime number. It is not divisible by any number except 1 and itself. So now this has become an improper fraction. Now if I tell you to convert this improper fraction into a mixed fraction, what will you do? Simple, you will just do like this. It is 19 divided by 6. So 6 3s are 18. You will get 1. So the quotient becomes the whole number 1 and 6 will be the divisor always. Okay. Easy, no? Simple. Now here also I have unlike fractions. So if I am having unlike and I have to perform addition or subtraction, I will have to first make it a like fraction. Okay. Or else you can even simplify 2 by 4 and you can simplify this. Like if you want to, you can do this as, see this. 2 1s are 2. 2 4s are 8. So it became a similar fraction, like fraction. Now simple add. 2 plus 1 3 divided by 4. So it will be 3 upon 4. Any which ways you have to change the unlike fractions to like fractions. Now subtract the numerators and keep the denominators same. Even here same, denominator is the same. Subtracting of the fractions, because the denominator is like, it is known as like fractions. Only the numerators I will subtract. 7 upon 5 minus 3 upon 5 will be 4 upon 5. Okay. Now there are unlike fractions. So for unlike fractions you have to make the denominator same. Now this is some other way. They have multiplied 9 to 3 and then 3 into 9. What I would have just done is I would have made this 3 as 9. So 3 into 3. So here also I would have multiplied only by 3. I don't need to change this 9 because I know 9 is going into 3. No, it's a divisible by 3. So I will say 7 minus 2 3s are, it is 6 upon 9. So you will get 1 upon 9. Same answer. This will be 1 upon 9. 3 1s are, 3 9s are. Simplest form. Okay. So now this is a pie diagram. If I tell you to put it in the form of fraction, so you will say this will be 1 upon 2, means basically it is 4 upon 8. But you can say 1 upon 2, this is 3 upon 8 and this will be 1 upon 8. So in the case of a diagram, if you see, if I'm asking you to subtract, you can just convert this as a like fraction. So if I'm converting this, I will say into 4 into 4. 4 minus 3 is 1 and here it is 8. Okay. See, unlike, there is the unlike numerator. So they have made both the denominator common. So if I'm making both the denominator common, I'll have to multiply this by 6. So numerator also have to multiply this by 6. If I'm multiplying 6 by 24, numerator also have to multiply by 4. So then I'll get 6 3s are 18, 1 4s are 4 upon 24. I'll get 14 upon 24. So now this 14 upon 24, they have simplified it with the help of the table. Okay, 2 table. So 2 7s are 14, 2 12s are 24. As much as you can simplify, you can. Okay, you will always obviously have the MCQs. Now multiplication is very easy. Multiplication, multiply the numerator, multiply the denominator and then simplify. So here 2 3 2s are 6, 4 5s are 20. Now you can simplify by the 2's table. 2 3s are 6, 2 10s are 3 upon 10. Multiply 1 upon 3 into 3 upon 5. Now this is very easy. When you get something like this, in the numerator and denominator one same number is there, directly you can have 1 by 5. You want, you can of course do this 3 upon 15. 3 1s are 3, 3 5s are 15. Same thing. Okay. So these are some short tricks which we use. Now how to multiply fractions? By fractions, I just showed you. 1 into 3 will be 3, 2 4s are 8. Then by whole numbers. So whole numbers, simple, whole number is nothing but it is 2 upon 1 only, no? 3 upon 8 into 2 upon 1. 3 2s are 6 upon 8. Mixed numbers, you will do multiplication and add. How to convert the mixed numbers into fractions? Sorry. First I will just show you this. How to convert a mixed fraction into a improper fraction. Mixed. 3, 2 and 3. Nothing. You will put a multiplication sign here. Addition sign up. So 3 3s are 9. 9 plus 2, 11. Improper fraction. Same thing you will do 4 into 5 plus 1. 4 5s are 20 plus 1. 21 upon 5. So this will become 11 into 21 upon 15. Okay. If you want, you can simplify this. 3 5s are 15. 3 7s are 21. So 77 upon 5. And then again they have converted this into a mixed fraction. Okay. You can convert that again into a mixed fraction. Clear here? Now see division. Whenever there is a division of fractions, just flip and change the sign. Change it to multiplication. So 1 upon 4 into 4 upon 5. When I'm changing the division into multiplication, I will flip the next fraction. So answer will be 1 upon 5. Always do the reciprocal in case of division. See this. 2 upon 5 divided by 2 upon 3. When I'll change this into multiplication, the next fraction I will do the reciprocal. So 2 and 2 will get cancelled. 3 upon 5 will be the answer. See, again one more example. Okay, so this answer will be what? 1 upon 2 into 4 upon 1. So 4 upon 2. 2 1s are 2 2s, answer is 2. One whole number. See, how to divide the fraction? Same thing. Again, so this you can do it as a homework. Easy. And whenever there is an improper fraction, you can make it a mixed fraction again. Okay, if they are asking the answer in mixed fraction, you will get a mixed fraction back. Okay, by dividing. Now see this. A upon B divided by C upon D is nothing but A upon B into C upon D. So AC and BD. Okay. Here. 12 is a whole number. They are dividing that 12 by a fraction which is 3 upon 5. So when I am dividing, I will change that into multiplication. Sorry. Here. So 12 into 5 upon 3 I will do. Now this whole number and this I can divide. 3 1s are 3 4s are. So the answer will be 20. 4 5s are 20. Now whole number, then there is a decimal point, and any number after the decimal point is known as the fractional part. Okay, so now the fractions is over. Now we are coming to the decimal part. Okay, so this part was decimals and fractions, no? So let's understand the decimal part. So the number before the decimal is known as a whole number. After the decimal point is known as the fractional number, fractional part. Okay, so if I am saying 0.7, I can write that as 7 divided by 10. One place after the decimal I put a 0. So 10. Okay, one place. Let's come here. Then one place after the 9 upon 10, 2 upon 10. If there are two numbers, two parts after the decimal, I'll put 2 zeros. So 100. 45 upon 100, 12 upon 100. And if there are three decimal parts, three fractional parts after the decimal, I'll put 3 zeros. Okay. Clear? So even there was one sum, you remember, 0.125. We had to convert that into a fraction. So 125, if I'm see this same thing, divide by 1000. So you can do it this way only. 125 divide by 1000, and then since they wanted in the form of fraction, therefore I had done the since they wanted in the form of fraction, 125 ones are into 8. 125 into 8 if you will do, you will get 1000. Okay. Now see this. So there is a decimal point. Before the decimal point, it is the whole number part. So you have ones, you have tens, you have hundreds, thousands, 10,000s and 100,000s. After the decimal point, we immediately begin with tenths. There is no ones. Okay, so there is tenth, hundreds means 1 upon 100, 1 upon 10. Thousands, 1 upon 1000, 1 upon 10,000, 1 upon 100,000. Okay, so they may ask you certain MCQs in which they will ask you to find the place value. Okay, place value of a given decimal. See this. So if I am writing this number in a form of decimal, 7th, it is 7/10, 400th. Okay, and 8 ones, 2 tens, 500s, 3000, 3528.74. This is how we pronounce or speak, about the decimal numbers. So this number can be written in the following values. Value is important. 3 is in the thousand value, so 3000, plus 5 is in the hundred value, 500. 2 is in the tens, so 20. 8 is in the ones, plus 0.7. 1 upon 10 is nothing but 0.7, and 4 will be 0.04, hundredth value. Okay, so this can be a part of your important MCQ. This is important. Write the digit in the hundredths place, hundredths, not hundred. Hundredths place for the given number 39.4546. Okay, so 39.546. I wrote this number. 9 is in ones place, 3 is in tens place, 5 is in tenths place after the decimal, 4 is in hundreds place, and 6 is in the thousands place. So if we refer to the chart, in the hundreds place we have which value? 4. 0.04 is the value which we have in the hundreds place. 0.04. This is how it is written. Okay, 0.04. So how to write this in the form of values? 30 is in tens position, no? So 33 is in tens position. So 39 is in ones position. So you have 9 plus 0.5 plus 0.04 plus 0.006. Okay, clear here? Chalo. Find the place value of 7 in the given decimal number. It is in the hundreds place. 7 is in the, not in the tenths place. 2 is in the tenths place. 7 is in the hundred place, and it will be written as 0.07. Okay, write the digit in the tenths place in the given number. Tenths place, 8. Okay, so it can be written as 0.8. Value is 0.8. Okay, again the same thing. Converting decimals into fractions. Yeah. Here. If I tell you 0.25, convert it into fraction. So you can, this is nothing. This you can just skip it. If I am telling you 0.25, convert that into a fraction. So you will say 25 upon 100. 25 ones are 25 fours are. 0.8 I can convert it as 8.10. Simplify form. I can simplify it, no? 2 fours are, 2 fives are. 4.2 if I want to change it into a fraction. Okay, 4.2. So I can say 4.2 is nothing but 4 as a whole number, and this 0.2 which is in the decimal, it is nothing but 2 upon 10. This I can simplify. 2 ones are, 2 fives are. Similarly 5.12, 5 is the whole. 0.12 is nothing but 12, 2 zeros, no, after the decimal, upon 100. This I can still simplify. 4 threes are, 4 25s are. Okay. So denominator, if it is a power of 10, denominator is the power of 10. So decimal fractions and non-decimal fractions are there. So if there is a power of 10, 1 upon 10, I can write this as 0.1, 0.3. This I can write it as 0.05. This I can write as 0.286. Okay, if I want to convert it into decimal, I'll take 3 places behind, and if I want to convert it into fraction, 3 places ahead. Okay, non-decimal fractions are also there. Converting, this is again repeated. Okay, now 3 upon 5 into into 2 upon 2. So 6 upon 10. Now if I am writing now 10 down. Okay, so whenever I am writing 6 upon 10. So 1 decimal point, no? So you will just move 1 point behind. So it will be 0.6. So I can write 3 upon 5 as 0.6. Okay. Converting again fractions into decimals. 3 upon 4. Divide the numerator by the denominator. Okay. And if it is decimals, write the fraction and simplify. So how will I write this as a fraction? It will be 0.4, no? So 4 upon 10. Simplify. 2 2s are, 2 5s are. Okay. This is easy. We have already done this. Okay. Now 6 upon 25. What I did is, I have made it common. I want to kind of make it in the form of decimals. Okay. So in the form of decimals, 6 upon 25, I have multiplied this by 4 and this also by 4. Numerator and denominator by the same number. So 24 divided by 100. In order to get this 100, I have multiplied this by 4. So this also I will multiply by 4. Once I get this as 100, if I move 2 points to my left, I will get 0.24 in the form of decimal. Okay, then there are a few sums. Okay, over here. How will you make this? How will you convert this into decimal? When you will multiply 5 by 2. If you are doing this, numerator also you have to multiply. Then only you will get 4 by 10. 50 into 2 if you will do, you will get 100. So here also you have to multiply by 2. 6 upon 100. 6 upon 100 will be nothing but 0.06. Similarly 25 into 4 you have to do here. So when they are asking you to convert, you have to just see how you were going to get 10, 100, 1000. Okay. Now there are certain examples on fractions and decimals. Okay. Say Karan has purchased 50 computers from a local computer market, only to discover that 10 of them were defective. Can you calculate the fraction and the decimal from the defective computers in relation to the total computers? How many are defective? 10 out of how many? 50. So this is the fraction. Basically we have the fraction of 1 by 5. Okay, fraction of 1 by 5. 10 by 50, it can be converted into decimal. 1 by 5 can be converted into decimal and the answer will be 0.2. If I want to convert this in the form of percentage, I will say 10 upon 50 into 100. Right? 5 ones are 5 twos are 10. 20%. 20% is nothing but 0.2. Similarly, there is one more example. In 100 office employees, 50 people chose burgers as snacks while others chose mango juice. Calculate the percentage of employees that choose mango juice. So out of 100, if 50 have chosen mango juice, so 50 upon 100 into 100, 100 and 100 cancel, 50%. 50% is nothing but 50 upon 100. So that will become how much? 0.5. Write half into in its decimals. Okay, to get half, I have to write it into decimals. So, to get 100 in the denominator, multiply the numerator also by the 50 and denominator also by 50. 50 upon 100. Okay. So, you will get this as a 0.5. 5 divided by 10 is nothing but one place decimal, you will take it on the left hand side, 0.5. Okay. Now there are certain sums which you can just solve this as a homework. Okay, multiplication and you can subtract. So these are very easy sums. You all can just do solving of these sums as a homework. So that is it with the decimals and the fraction parts. You all just need to know how to convert a fraction into decimal and a decimal into a fraction. Okay, so this was your part 2 of your first lesson of quantitative aptitude. If I will get certain more solving sums like simple ones, I will put it on the same group. Meanwhile, you all can just practice these little sums, MCQs which are there and all the examples which we have solved here. Okay, everyone? Thank you. Okay, so now this is the part 3 of your first chapter, number systems of quantitative aptitude. Okay, so this is the last part of this chapter. Very easy number relationship. The relationship which a number can have with another number, whether it is equal to that number or whether it is greater, whether it is less than that number. Any relationship which can be established between two numbers. Okay. Then we have there are 3 things in this. One is relationship, connection. One is the Cartesian product, a method of creating all possible pairs from 2 given sets. Okay. And then types of relationship, symmetric, transitive, reflexive, whatever is the relationship. So now understanding the first basic ones which we have learnt in our school when we were kids. Okay. So we know equal to sign, we know greater than sign, and we know a less than sign. Okay, so if I am writing a number 7 and 5. Okay, say I have written 7 and 5 and I am asking you to put a sign of greater than. So it will be like this. Right? If I am writing 3 and 3, it will be an equal to sign. If I am writing 5 and 7, it will be a less than sign. Right, so relationship greater than, equal to and less than. Okay, so these are the symbolical description. Greater than sign, less than sign, equal to, not equal to, greater than and equal to. This is also one sign. Greater than and equal to and less than and equal to. Okay, there are students which are equal to 30 and greater than 30, less than mangoes which are less than but equal to 40. Okay. Then, okay, MCQs here for the first type relationships. Which of the following pairs is correctly related as less than? Okay, so less than is only one pair. This 5 is less than 7. If 5 is related, if 15 is related to 10 by the greater than sign, okay, they are saying 15 is related to 10 by greater than sign, then which has the same relationship? Greater than sign. 12 is greater than 8. Same relationship. Greater relationship. Which of the following is correctly shown as a relationship of equal to 7 by 7? You will say, ma'am, seriously, these type of questions. So yes, these type of questions, and you are going to get marks for them. And imagine if you are going to skip all this and not do it, might as well just do it, revise it. It is so fine. Nicely, you can just go through it, revise it also. It will be like brushing up of all your old concepts in case you all have forgotten. Okay. If the relationship is less than, holds true for 2 and 5. Yes, it holds true for 2 and 5. Less. Something wrong with this page. Okay, 2 and 5. Obviously less than. Which of the following pairs do not satisfy this relationship? So, 9 is less than 4 is not satisfying this relationship. This is totally wrong. 3 is less than 8, 6 is less than 10, 1 is less than 10. All are correct. Okay. Then what is Cartesian? Okay, it is the organizing items in a pair named after René Descartes. Okay, so they are talking about, say there is an example, one is colors and one is object. So in set A, I have got two colors, red and blue, and in B, I have got two objects, bag and shirt. So I can have various combinations. I can have red bag, red shirt. I can have blue bag, blue shirt. Okay, so it's a combination given between the elements of two given sets. Okay, so this is what is a set. So set is nothing but it is a collection of objects or elements. Now this is a set of all even numbers, 2, 4, 6, 8, 10, 12. Okay, all even numbers. Empty, where the element is 0, there is nothing there only in that set. So if I tell you A is a set of a natural number which is less than 1. Is there any natural number which is less than 1? Less than 1 is 0. 0 is not a natural number. So it's a empty set. How it is denoted? Like this. Okay, it is denoted by A is equal to curvy brackets and there is nothing in that. Or you can write 0 and put a slash on that, which is an empty set. Or you can say finite set means innumerable elements are there. You can't count. Finite means there is a specific number of elements. So if I am telling you natural numbers less than 6, so 1, 2, 3, 4 and 5 less than 6. But if I tell you natural numbers, all the natural numbers, then from 1 till infinite sets. Okay. Then certain operations, here you have, this is U is a universal set, in that you have set A, you have set B. A and B where they are intersecting, A union B, right, intersection B, A intersection B. Then A union B is nothing but addition of both the elements of the set. A complement, set of A complement is means all the set of the universe leaving only the set A. Everything present in the universal set except in set A, that is A complement. Then you have two disjoint sets, there is nothing common between A and B. Then B has, A has all the elements, in fact more elements, but B is a subset. Okay, so say if I say in set B, you have 1 and 3. And in set A, there is 1, 2 and 3. So B becomes a subset of A. Okay, proper subset of A. And it is denoted as B is a subset of A, this sign. Okay, this sign. Then both A and B where they are intersecting A intersection B. And addition of all the elements of A as well as B is known as A union B. A intersection B, A in union B, subset of a set, all this is important. This you have to remember. Okay, this all 1, 2, 3 things are important, whatever I have given in the diagram. See this. So if I am saying set, in set A there is 1 and 3. Okay, set B 2, 3 and 9, and in set C there is 3 and 9, collection of all objects. Intersection of set A and B means what? Common element. It is belonging to both A as well as B. So what is belonging to A and B? Only number 3. Union means adding all the elements of both the sets, but do not repeat. Any set cannot have a repetitive element. Okay, so I will say 1, then there will be 2, 3 and 9. That will be A union B. Subset, okay, it is a set contained in another set, right? So that can be a subset. Not a subset means there is no a set which is not contained in another set, it will not be a subset. So they can ask you an MCQ based on that. Superset means there is a C is the superset. Why? Because set C B is the superset over here. Superset means set B is also including set C. All the elements of C are present in B. Okay, same like how we just did a proper subset. If I say 3 is a element of A, it's a member of A. Okay, 4 is not an element of A, it is not a member of set A. 4 is not a member, not present in set A. Okay, so these are important from your MCQ point of view. So now, what is a set? It is a collection of objects or elements. Okay, this is the right answer. Which of the following will represent an empty set? The set of all whole numbers, the set of prime numbers, set of natural numbers less than 1. This will be an empty set because there is no natural number less than 1. Okay, it will be an empty set, or you can write it as this. Okay, I have given explanation to each of them. Which of the following is an example of a finite set? Means there are specific number of elements. Set of all even numbers, set of all integers, the sets of months in a year, set of all natural numbers. Can you count all the even numbers till infinite? No, they are infinite. Integers infinite. Months of the year finite, 12 months in a year. Okay, 12 months in a year. It is a finite set. Answer is 3. Which of the following is an example of an infinite set? Vowels in English alphabet, they are finite. Days of a week, finite. Planets, finite. Natural numbers, infinite. What does this symbol mean? This symbol is intersection. Intersection. So elements present in both the sets. Okay, intersection of two sets. Okay. See, in set A we have 1, 3, 5 and in set B we have 3, 5, 7. So if I am asking you A union B, I have to add up. Okay, so when I am adding up, I will write elements of A. Okay, and I will also write elements of B. I will not repeat. I will not write 1, 3, 5, 3, 5, 7. No, only once I will write one element. Okay, so A union B is nothing but the addition, which includes elements in both the sets. In either A or either B, I mean to say. Which symbol indicates that one set is a proper subset of another? It is a proper subset of another. This indicates. Meaning what? All the elements of the first set are in the second set, but they are not equal. They are not the same. But there is one set which has all the elements of another set also. Okay. They can be equal sets also, but they are different. Now, types of relationship. Empty relation, there is no connection. There is no, if there are no common friends between two group of people, there is no relation based on friendship. Universal, every item is connected to every another item. In a team where everyone has worked with everyone else. Example. Reflexive relation, each item is connected to its own self. Okay, each person knows their own phone number. It is a reflexive. Okay, symmetric, one item is connected to another. So A is connected to B, B is connected to C. Sorry, if symmetric will be, if I say A is connected to B, I can also say B is connected to A. Okay, transitive relationship is where I can say A is connected to B, B is to C. So I can say A is directly connected to C also. Okay, so now MCQs on this type of relationship. Which of the following is an example of reflexive relation? Reflexive means you are connected to your own self. Okay, you know it by your own self. John knows Mary. John knows himself. This is the best one. John is taller than Mary. John and Mary are friends. Nothing will suit in a reflexive relationship. Okay. Which of the following describes a symmetric? Symmetric relationship means A knows B, so even B knows A. Same thing. Okay. If John is friends with Mary and Mary is friends with John, if John is taller than Mary and Mary is taller than John, this is so something which is not there only, like it could not be possible. If John knows Mary, Mary knows Alex, John knows Alex, this will be a transitive relationship. If John doesn't know anyone in the group of people, this will be an empty relationship. So this is the answer. John and Mary. John is friends with Mary, so obviously I can say Mary is a friend of John. Okay. Which one of this is a universal relationship? In a group of friends, nobody knows each other. Empty. This is the first one. Okay. Everyone in a class has met everyone else. This is a universal relationship. Only one person in a team knows everyone else. So this will be a reflexive relation, known to herself. Two people know each other but not everyone. Symmetric. I can tell you each relationship over here based on the. So the answer is 2. Now there is little bit of MCQs. Let's see. Fraction related MCQs. Okay, these are like little simple ones also and a little tricky, but they are there in the last part, so we will just solve it. If half of 1/3 of a number is 20, then half tenth of that number is how much? Okay, now you will say that ma'am, look at the question only, how it is sounding, but it is very easy. See, I'll tell you. Let the number be x always. They are saying if half of the solve with me, of the 1/3 of the number is 20, then half tenth of that number we have to find. So based on this first equation, I can say x upon 6 is equal to 20. Therefore x is equal to 6 into 20 is 120. So I got the number. Now they are asking me half tenth of that number. Okay. So first if I say tenth means 1 upon 10, 12. For that also they are asking me half of this. So half of this will be what? 6. Answer is 6. They are asking me half tenth. Okay, half tenth of that number. Now see, similar. One more we will solve, you will get confidence. If 1/5 of a number, let the number always be x, is 40, is means equal to 40. What is 1/10 of that number? That we will find. First let us find x. So x will be 40 into 5. X will be 200. I need to know 1/10 of that number means 1 upon 10. So the answer will be 20. Understanding? Next one more we'll do. 1/4 of a number means x. Okay, is 16. What is 1/8 of that number? So we'll see. X will be equal to 16 into 4. Okay, so X will be equal to 64. They are asking me 1/8 of that number. 8 8s are 64. Answer will be 8. So first find the number and then find the what they are asking the next. If 1/4 of a number is 10, if half of 1/4 of a number is 10, then what is 1/4 of that number? So I will say x upon 4 2s are 8. So x is equal to 80. What is 1/4 of that number? 4 1s are 4 20s are. Answer is 20. Then there is difference and digit manipulation. The difference between a 2-digit number and the number obtained by interchanging the position of these 2 digits is 54. What is the difference between the 2 digits? Okay, now basically I will say let the number be A and B. Okay, let one number be A, let the other number be B. So it is a 2-digit number, so A is in the tens, B is in the units. Now they are saying the difference between the 2-digit number and the number obtained by interchanging their position is 54. What is the difference between the 2 digits number? So they are saying if there is this number, 2-digit number A and B, the difference by interchanging. So when I am interchanging, it is becoming 10B plus A. The difference like this. Okay, so there are these two numbers and the equation is like this. So I can say 10A plus B, I'll open the bracket, minus 10B minus A will be equal to 54. So I'll get 10A minus A will be 9A. Minus 10B minus B will be 9 minus 9B. That will give me 54. A minus B, 9 outside, will give me 54. So A minus B will be equal to 54 upon 9. Okay, so A minus B will be equal to 6. So answer is 6. So I told you let one number be A and one number be B. The difference between A minus B we have to find. Okay, now they are saying what is the equation, how we will form the equation. That first I took 10A and B. Why I took 10A? Because A is in tens, B is in ones position. When I am interchanging them, I am making 10B and A in ones position. The difference between these two numbers is coming as 54. Okay, when I solve this equation, my answer of A minus B will be 6. So this will be the answer. Same is the next question. Difference between 2-digit number and the number obtained by reversing its digit is 27. So instead of 54, now here it will be same thing, it will be A minus B will be 27 upon 9. This will be 3. And similarly you have to do this practice MCQ 2. Same thing. 9A minus B, they are getting 45. So A minus B will be 45 upon 9, which is equal to 5. So these are the type of sums which they have given by the institute for us to just know and solve them. Okay. This also you all can solve by yourself. So this is it. This is like a homework. So you all can solve these sums. This is also there on the group. Okay. All your notes along with the video will also be available. And I am going to meet you all soon for the other chapter. So we are done with the entire chapter. First chapter, number systems of quantitative aptitude in 3 parts. So this was the last part, number relations, and we are done with the number relations. Okay, so thank you all. Thank you so much. Bye.
Thank you.
So hello everyone. Now this is the last part of your chapter fundamental arithmetical operations, which is about profit and loss. Okay, very simple topic. We all know how to calculate a profit and loss. Okay, so say if I tell you that the yearly sales was 2000 and the expenses for making this sale is 1000, I am left with a profit of 1000. But say it was other way around. I say that my yearly sales was 1000 and expenses were 2000. I am left with a negative 1000. That means this is a loss. So in case of businesses and in case of accounting for corporate accounts, any type of accounts, we definitely need to know the profit and loss. Okay. So we need to know how to calculate. So in any trade of business, profit and loss is the crucial thing. We run a business for the profit, okay, for having some extra beneficial amount over the expenses, correct? So how to calculate profit and loss is important. Profit also relates to the word known as gain, and loss is the opposite of profit. So say P, profit. A product is sold at a profit if the price is higher than the cost price. Obviously, say I brought the land for 1,20,000. When I got it, I paid 1,20,000. And then I sold it for 2,20,000. So I made a profit of 1 lakh rupees. Loss will occur when my purchase price is more than my selling price. So say I purchased the laptop for 50,000, but when I sold it at 35,000. So I suffered a loss of 15,000. Cost price is that price at which the product is being purchased. Okay, it also covers additional costs like overhead, transportation to bring that product in use, whatever cost you have done. So say for example, Shiva had paid 20,000 for air condition, but after he purchased it, 1,500 was for shipping, 2,000 they took for installation. Unless I'll not install the AC, how will I use it? So my final cost is not only 20, it is 20 plus 1,500 plus 2,000, that is 23,500. For me, the cost is 23,500. Okay. Fixed cost. They are such cost which will not change due to situations. Okay. So say today rent, if I am running classes from a given, I'm running this from a given place and I'm paying a rent. So even if I'll have 10 students, I'm going to pay that rent. Even if I'll have 100 students, I'm going to pay the same rent. Right? It's not going to change. It's not going to vary with the situation. But variable cost will vary. Number of students, I had to make that many number of notes. I had to correct that many papers. Right? It is varying depending on the situation. So fixed cost, variable cost, okay, all this is important for your theory MCQs. Selling price. It is the price at which the product is offered for the sale. Okay. So it can be greater than, equal to, or lower to the cost price. If it is lower, obviously it will be loss. Greater, it will be profit. Same, there will be no profit, no loss. For instance, if a store owner purchased a table for 800 and then he sold it same for 1000, so purchased it for 800 and sold it for 1000, the furniture's cost price is 800 and selling price will become 1000. Market price. Marked price or market price, shop owners essentially label this to provide discount. So what they do is they will purposely first write 1200 and then they will say that I am going to give you a discount of 10% on this. So 120 rupees less only you have to pay. Okay, so discount will be nothing but your marked price minus, say, selling price is 1100. So see the 100 rupees we got it as a discount. If I want to find the discount percentage, I will always take the amount of discount divide by marked price, original price, okay, into 100. Clear? Profit percentage It is the percentage of profit on price on which the product was purchased or manufactured, etc. Loss percentage, you can also be the percentage of loss. It is the percentage of loss on the price on which the product was purchased, manufactured, etc. Profit and loss formulas. When will I have profit? When my selling price, I subtract my selling price from my cost price, I will have profit. But my cost price is more than my selling price, I'll have a loss. Profit percentage will be nothing but profit upon cost into 100. Similarly, loss percentage is nothing but loss upon cost into 100 always. Okay, so now let's see some examples. Let's use profit and loss to more easily comprehend this idea. Consider a shop owner. He purchases a dairy from a market rupees 16. Now this dairy he sold for 20 rupees. So the cost price is 16, selling price is 20. Therefore for me profit is SP minus CP. 20 minus 16, which is 4. Easy, simple. Now what is the profit percentage? If I want to find profit in the form of percentage, I will take profit upon cost price. Cost price over here is 16 into 100. Okay. So profit percentage will be 40, 4 ones are, 4 fours are, 2 twos are. Okay. So profit percentage actually it is 20%, 25%, not 20%. Okay, not 20%. It is 25%. When you will solve this, you will get 25% as the answer. 25% of the cost price. Okay. Next question. Okay, now there is one formula table I have given. If the cost price is less, selling price is more, you will have profit. Cost price is more, selling price is less, you will have loss. Okay, so this is done. You can interchange it if one variable is not given. In order to find the selling price, I will add this to cost price plus profit. I know my cost is 10. I want 2 rupees profit, so I will make my selling price 12. Similarly, cost price, in case of loss, cost price will be what? Selling price plus your loss. Okay, in case of profit, cost price I can find when I can subtract the selling price with the profit. Here I can find the selling price by subtracting the loss from the cost price. Profit percentage, loss percentage. Okay. Suppose now certain sample questions are there. Suppose a shopkeeper has bought 1 kg of mangoes for rupees 120 and then sold it for 150 per kg. How much profit did he earn? So his selling price is 150. Cost price is 120. See the I know this is a profit because selling price is more. So profit will be equal to 150 minus 120, 30 rupees. Simple. Profit earned by the shopkeeper. Calculate the percentage of profit gained by the shopkeeper above. So percentage of profit will be nothing but the amount of profit upon the cost price into 100. Amount of profit is 30. Cost price is 120 into 100. Okay. Now 2 6 are 12, 2 5s are 10. 6 1s are 6, 6 5s are 30, 5 5s are 25%. See? Okay. Next question. A man buys a cooler for rupees 2000 and then sold it at a loss of 15%. What is the selling price of the cooler? So first I'll have to find the loss percentage. Okay, loss percentage is given. I'll have to find the loss amount. Okay, so loss percentage is nothing but loss upon the cost price into 100. Loss percentage they have already given me 15. So I have to find the loss upon 2000 into 100. So 15 into 20 will be my loss. 15 twos are 30. 300 is my loss. I got the loss. I know my cost price. Okay. So cost price of the cooler is 2000. Loss I know that it is 300. So selling price I can find. Correct? Now I can find the selling price. Selling price will be nothing but the cost price minus the loss. Cost price is 2000. Loss I found is 300. So I sold it at a 1700 rupees. Only then I got loss of 300. Clear? So these are the type of questions which you can have it for the profit and loss section of this chapter. Okay, so you all need to remember this table properly. Okay, once you all know the first formula, profit is selling price minus cost price and loss is cost price minus selling price, everything else can fall in place. It is just interchanging from the other side of the equation sign. Okay, so this is it with the profit and loss. And with this we have completed this profit and loss section and the entire chapter of fundamental arithmetical operations. Okay, thank you so much everyone. I hope you have found this video and this session useful, and it has been helpful to all of you. Study well. All the best. Bye. Hello everyone. Welcome back to our quantitative aptitude subject for CSEET English lectures. Okay, so I have already completed lesson which was about number systems for quantitative aptitude. We have done everything in that. We have done types of numbers, decimals, fractions, number relations, all that is being completed. Okay, so you all can go ahead and revisit those lectures. Today we are going to complete fundamental arithmetical operations, which is your other chapter for quantitative aptitude. Okay, this is more of a practical subject, so more of practical questions are going to be asked. So the theory part you all can just read it once. There is nothing much there in the theory. Basic theories have been given on based of which we are going to solve the sums. Okay, so let me make myself clear. This is something which is the most simplest. It is even simple than number systems. Okay, so we are going to talk all the operations which we do, arithmetical operations which are important for our studies. Okay, so according to Britannica, arithmetic is a Greek word and it is derived, which means arithmos, a number. Okay, so when you are doing certain operations with those numbers, it becomes an arithmetical operation. So basically we are talking about everything relation to addition, subtraction, multiplying, dividing, raising it to the powers, extraction of roots, etc. Okay, so when I'm talking about all these type of mathematical expressions of addition, subtraction, multiplication, division, there are certain rules which we need to follow when we are solving those type of operations. Okay, so the most important rule is the BODMAS rule, wherein any operation, first there are steps. Okay, you can just not solve any mathematical operation randomly. So there are certain rules which we follow, and the most important rule is the BODMAS rule. It is also known as DMAS rule. Why? Because everything we do first with division, then we start with multiplication, then we go for addition, and then last comes the subtraction. So what is BODMAS? B stands for bracket. Anything given in the bracket of the operation, we do it first. O stands for the order in which the sum is given. D, of course, division. M is for multiplication. A, addition, and S stands for subtraction. So you will notice all the sums which we are going to do, we will be doing it in this format throughout all the sections of this chapter. Okay. Now, what are the sections? There are 7 topics covered in this chapter. Those 7 topics are: the first one is a basic arithmetical operations, in which we are going to do addition, subtraction, multiplication, division. Then we will move to percentage. Then we are going to go to ratio and proportion, square roots, interest, simple interest, compound interest, average, and profit and loss. So there are 7 subtopics for this particular chapter. Okay. So now we are going to begin with the first one, which is the basic mathematical operation. So if you see, I have just put one image for you all, which says addition means when you are adding plus sign, subtraction is when you are subtracting over here, it is the minus sign. Okay. For multiplication, times sign, and for division is the division sign. Okay. So example for basic mathematical operations, I am going to move to the example directly so that we can understand the theory in the better form. In theory, they have given everything related to the example. So if I am telling you that add 2 integers, so you are going to put a plus sign. I have integer 2 and 5. So in order to add them, I'll put a plus sign. So 5 plus 2, I'm going to get 7. But if I tell you subtract 2 from 7, that means I'm asking you to write 7 first, subtract 2 from 7. Okay, the words are important. They are not asking you to subtract 7 from 2. If you will do this, you are going to get, you have to subtract only. You will get the answer 5, but you will get a negative integer. Okay. Next is multiplication and division. Okay, so if I am asking you to multiply, say 8 into 10, I'll get 80. And if I am asking you to divide 80 by 10, you will get 8. 10 ones are 10 eights are. Right? So this is the level of simplicity you can expect from this particular topic. Okay. Now, certain types of fundamental operations is addition, subtraction, multiplication, and division. So each 4 of them we are going to discuss it separately. Okay. So what is addition? When you are bringing the items together, numbers together, you put a plus sign over there. It is known as addition. Okay. When you add, you create a single number. Okay. So you can add even the fractions. You can add decimals also. So here see, 9.12 plus 1.88 we have added and we get the answer as 11. Okay. Again, I am repeating myself. We are not allowed to use any calcs in the exams. So basically, generally also they are not going to ask you any complicated numbers. They will ask you those which are possible to solve by yourself. Okay. So when I am doing addition, there are certain rules which I have to keep in mind. Okay. So all the addition rules are that if I am adding 2 positive numbers, okay, if I am adding 2 positive numbers, I'll get a positive 2 positive integers will give me a positive number. Negative integer, okay, is created when there are adding by 2 negative integers. Okay, so now basically what is happening here is, if there is a same number, positive integer, I am going to get a positive number. But if I am having like this, negative integer, minus and minus always add, but it will be a negative integer. The result also is going to be negative. And say if it is like this, minus 2 plus 7, one integer is negative, one integer is positive, we will always subtract. Always. One positive, one negative, we will always subtract. You will get the number and the sign of the greater integer. Here the greater integer is 7. Clear everyone? Okay. I'll move forward. Anywhere you all find any problem, please ask questions. Okay, same thing we are going to do with subtraction. Okay, when we are talking about difference between two numbers, between two integers, we denote it by the sign which is a minus sign. Okay, so say for example here they have given me that what will be 14 minus 5? 14 minus 5 will be how much? 9. Correct. So a difference between the two numbers can be denoted by a minus sign. Okay, now see this, 14 plus, in the bracket they have written minus 5. This means what? As per the BODMAS rules, I'll open the bracket first. So in order to open the bracket, this plus sign with minus sign will always become minus, and it is going to be, here it is going to be 5. So here if you see that there is an addition of one positive integer and one negative integer. There is an addition happening of one positive and one negative integer. So the result will always be the difference. Okay, so therefore 9 and the sign of the greater integer, same thing. So for subtraction, what are the rules? That both the numbers are positive. Sorry. If both the numbers are positive, the answer will also be positive. Both the numbers are negative. Okay, both the numbers are negative, the answer will also be negative. And if one number is positive and the other number is negative, the answer will be the sign with the largest number. Okay, sign with the largest number. So minus and minus you will always add. Minus and minus you will add, and you will get the you will get the positive integer. And when there is one negative and one positive, you will always subtract and you will put the sign of the greater integer. Coming to multiplication, when you want to, another name for multiplication is a repeated addition. Okay, to combine two or more values, you produce one single value, it is known as multiplication. Okay, so in the multiplication, say if I want to multiply 5 by 6, I will get 30. Okay, so here 5 is the multiplier and 6 is the multiplicand, and the result 30 is known as the product. Multiplier, multiplicand and the product. Okay, so A and B, if you want to multiply, they have given you the value of A, they have given you the value of B, you can multiply and get the product. Now rules. If you are multiplying two positive integers, okay, the number is positive. In multiplication, if one number is positive and the other number is negative, the answer will be negative. You will multiply, say minus 5 into 6. You will write 30, but the answer will be, the product will be in the negative sign. In a multiplication, if both the numbers are negative, minus 5 minus 6, then the answer is going to be a positive 30. Minus and minus sign will not be there. Okay, if there are two minus signs, then your answer, the product, is also going to be positive. Remember that. In division, okay, division means what? You are basically dividing it, a given number, into some parts. So if I am telling you divide 8 into 4 parts, okay, so you get the answer, the quotient will be the 2. So your 8 is known as the dividend, 4 is the divisor, and 2 is called the quotient. This is important. Okay, they may just ask you this example and then they will tell you which is the quotient in this. Quotient is the answer. Okay, 2. Like how in multiplication we get product, in division we get a quotient. Rules of division important. If there is a positive integer and you are dividing that by positive integer like 8 upon 2, obviously you are going to get a positive integer. Okay, but if you have minus 8 upon minus 2, so again you are going to get a positive integer. A negative integer is produced only when you divide two integers with different sign. If I am saying minus 8 upon 2, then I am going to get minus 4. If one is positive, one is negative, only then I am going to get a negative integer. Otherwise, if both are positive, I will get a positive quotient. If both are negative, again I am going to get a positive quotient. Clear everyone? Anyone has any doubt? I'll move to the next topic, that is basic arithmetic properties. Same thing, addition, subtraction, multiplication, division. But there are certain properties which we have. One is commutative, associative and distributive. Commutative means what? It is applicable, commutative is applicable for addition and in case of multiplication. What are they saying here? That if I am doing 5 plus 2, same thing, same answer I will get if I am going to do 2 plus 5. Correct? Basically, A plus B will always result to me into B plus A. Same thing you can do for multiplication. A into B will always give me B into A. So this is known as a commutative property. Okay, the result does not change. Associative property, say there are 3 numbers. Okay, like commutative, associative property is also applicable only for addition and multiplication, but when there are 3 numbers. So if I am telling you it is A plus B plus C, okay, so you can do it like this. You can have A plus B plus C, A and B you can put it in the brackets. Okay, so see, first example is 1 plus 5 plus 3 will be nothing but it will be the same as A plus B plus C. 1 plus, then in the brackets they have put 5 plus 3. So you first add 5 plus 3, 8. 1 plus 8, that will give you 9. Similarly, 5 plus 1 is 6. 6 plus 3 will give you 9. You first solve the brackets, no? Same thing is for multiplication. A into B into C will give you C into B into A. Same thing, okay? It is known as associative property. Here the result does not change even if you change the group of the numbers. Okay. And the last one is distributive property. When there are 3 real numbers, okay, 3 real numbers, and they have given you to multiply one number, and they have given you a group of other 2 numbers to be added. So distributive property means you will multiply A by B and you will again add and multiply A by C. Okay, so when you see this example, 5 into 3 plus 4, how am I going to solve this? 5 into 3 plus 4. That is nothing but 5 into 3 plus 5 into 4. When I open the brackets, I am going to multiply 5 by each of the real number in the bracket. So 5 into 3, it is going to be 5 3s are 15 plus 5 4s are 20. So this is going to be 35. Right? So you can put, they have given it to you in the form of equation, that even if you will do like this, you say 5 and 3 plus 4. How much is 5? 4 plus 3 is 7. This is also 35. And when you will solve it in A into B and A into C form also, you are going to get the answer 35. Okay. So the answer, the result does not change. Clear here? Come on. Now we are going to solve some sample questions on DMAS. Okay. First question. Add 30 and 45 and then subtract 20 from the sum. So read the question properly. They are first saying add 30 and 45. You got 75. I have given you all the answers also. And then subtract 20 from that. So 75 minus 20, the answer will be 55. Easy. Next question. They are telling me 10 plus 10 plus 10 plus 10. 5 times they have given me 10. So it is going to be 50. One another short way is that since all the numbers are the same, The number of time that number is repeated 5 times, I just multiply. Answer is going to remain the same. Now they are saying find the value of, now see this. Now here we will apply the BODMAS rule. Okay. 6 into 4 divided by 12 plus 72 divided by 8 minus 9. Okay. So brackets first you will solve. Whatever is given in the bracket, solve that first. So 6 into 4 is given first. So 6 4s will be how much? 24. Then we are going to go to the division sign. Then we go in the order and the division sign here divide by 12. Keep this plus sign as it is. One more division is there here. 72 divided by 8. And then in the end we will do the subtraction. So 24 divided by 12 answer is 2. Addition sign will remain as it is. 72 divided by 8 is 9. And here it is minus 9. So plus 2. Plus 9 minus 9. Plus 9 minus 9 also if you cancel you can get answer 2. Same number. One positive integer, one negative integer, 0. Or you do 2 plus 9 as per the BODMAS rule. So 2 plus 9 is 11 minus 9 also you will get 2. Okay, so these basics have to be strong. Then you can solve any sum. Now see this. Now they are saying simplify 24 minus 4 divide by 2 into 3. So as per, there are no brackets. So I will now follow the DMAS rules. First I will start with division. So 4 divided by 2 is how much? 2. Simple, I'll write 24 minus 2 into 3. Division is done. Then multiplication. So 24 minus 2 3s are 6. So answer is going to be 18. See. Next question. 24 divided by 4 into 3 plus 2. So again there is no bracket. So I'll start with the DMAS rules. So 24 divided by 4. 24 divided by 4 will be 6. Correct. Into 3 plus 2. Then multiplication. 6 3s are 18 plus 2. Answer is going to be 20. Okay. Then the next question. Simplify minus 20 plus 8 divide by minus 2 into 3. So first I will do the division. Okay. I'll keep minus 20 as it is. I'll put the addition sign also as it is. Now minus 8 divide by minus 2. Two negative integers will always give me a positive number. Positive quotient, that is 4. Right. Into 3. Then I'll do this multiplication. Minus 20 plus 4 3s are 12. I have one positive integer, one negative integer. I will always subtract. Okay. One positive and one negative, always subtract. And the sign will be of the greater number. So I'll get 8 as the difference. And sign will be of minus because 20 is a greater integer. Okay. Then 7th question. Minus 5 minus 48 divide by minus 16 plus minus 2 into 6. Okay. So first perform the division of 48 divide by minus 48 divide by minus 16. Okay, cut this minus and minus, it will give me a positive quotient which is 3. Right. So if I will say minus 5, okay, minus in the bracket if I am putting 3, it is a positive integer. Then I have plus minus 2, I am writing this as it is, into 6. Now after division I will do the multiplication. So when I will do multiplication I will get minus 5. I am opening this bracket. Minus into plus will give me minus 3. And here I am going to write it plus and in the bracket I will write the product. 6 2s are 12. One positive, one negative integer. Negative only 12. Okay. Now minus 5. minus 3, plus and minus again will become minus 12. Okay, so add this 2 minus, minus and minus will be always plus, but the sign will not change. Minus 12. Again minus and minus, it will always be addition. You have to add. Minus and minus, negative integers, two negative integers always add. But the sign will always remain of minus. Okay, everyone, clear? Come on, now solve this sum by yourself. It is very easy. First do the multiplication. Then do the addition. 2 6 are 12. Then here first do the addition. Now they have just kind of changed it. In order to do the addition, they have taken addition first and then they have done minus 12. So first you add this and then you subtract 12 from that product. You are going to get 57. Okay. Anybody has any doubts regarding these basic operations of addition, subtraction, multiplication and division BODMAS rules? These are the type of sums which they are going to ask you for your MCQs. Okay. So with this, I have completed your first session of this chapter, the first part, which is basic mathematical operations, these 4 operations with the BODMAS rules. Okay. Thank you, everyone. Hi, everyone. So now we are going to begin with the second topic, which is percentage. Okay, it is again it's a part of your fundamental arithmetical operations of your quantitative aptitude. I have divided this chapter in parts. So this is going to be your part 2, which is percentage. Very simple, very easy to solve, and basic sums are going to be asked in this also. So first thing, we have to understand what is a percentage. Okay, so if I want to know that there are 100 students in a class and only 20 have passed, so what is it is in the form of percentage? Or there are 200 students in class and only 20% has passed. So what is basically the percentage of passing percentage or failure percentage? Okay, so percentage is to give you a relative value over a whole value. Okay, so we have a specific formula to calculate the percentage. So whatever value for which you want the percentage, when you divide that by the total value and then you multiply that by 100, you are going to get the required percentage. Okay, so say in this example, I want to know how much is the percentage of value 3 over the value of 5. Okay, sorry, this is multiplication sign. So I am going to get 60%, 5 ones are 5 20s are 100, 3 into 20 60%. Okay. Similarly, if I want to know that there were 10 apples out of 200 apples, there were 10 apples which were bad. So what is the percentage of those bad apples? So the value is 10 of bad apples. Total value is 200. Multiply by 100. Simple. Always there is a multiplication by 100. 2 ones are, 2 5s are. So it is going to be 5%. But the answer has to be always denoted by a percentage sign. See here. It is denoted by a percentage sign. Very important. If we forget to write the percentage, then what? 5 will become a normal integer, a real number. Okay. Now see, I have taken basic sums. They are telling calculate 20% of 80. Now they will give you a percentage and they will ask you to find the value also. Okay. When I am saying 20% of 80 means what? 20% of 80. Whenever they give you any sum like this, convert this percentage sign, divide that by 100 and then multiply it by the whole value. Okay. So, right, 8 2s are 16. So I got the value. So basically they had given me the percentage 20. They had given me the total value also 80. They were asking me the value for this particular percentage. Okay, so basically if I am going to do 20% of 80, I am going to get 16, right? Next question, calculate 25% of 100. Same thing, I will do 25 divide by 100 into, the value is what? Total value 100. 100 and 100, multiplication and division you can cancel. The answer is 25. Third question, there are 30% of 400 apples which are bad. How many apples are bad? So 30%, I am going to write it in the form of 30 upon 100. Total value they have given me of the apples as 400. These zeros we can cancel. 4 3s are 12. 120 apples are bad. So basically 30% of 400 is giving me answer as 120. Okay. See now this. A mobile is reduced 25% in its price. The old price was 120. We have to find the new price. So first I will have to find the reduction. So the reduction is by 25%. 25% of the price which I already was selling. A mobile was selling at 120 rupees and there is a reduction in the price by 25%. So how much is the 25% of 120? This is what I have to know, right? So you can just do it by 2 times table. 2 5s are, 2 6s are, 5 1s are, 5 5s are. Since you are not supposed to use the calci, I am doing this also for you. So 5 into 6 is going to be 30. So by 30 rupees, we have to reduce the price from the base price. So our original price was 120. I'll have to reduce it by 30. So the new price is now going to be 90. Okay. Then we have variables of percentage. One I told you, you have the percentage. Then we have the part value. You say in this sum we had part value. Okay. And then we have the base 120. So this is base, this is the part, and this is the percentage. These are the 3 variables of the formula. Okay. Now in order to solve any percentage problem, you are supposed to identify these variables. So when we did the 80% of 20, say if I am doing 80% of 20, which is the answer is coming as 16. Okay. So 80 is the percentage. 20 will become the base and 16, the answer which we got, is going to become the part. When you will do 16 divided by 20 now into 100, if you will do this, see this. You are going to get it. You are going to get this as 80%. Right. Similarly, these are the MCQ questions. These are important ones. So if I am asking you 50% of 200, which is 100. So which is the percentage in this 50? The base is going to be 200 and the answer which we get is the part. Okay. Similarly, there is one more sum. 60 is 50% of 120. So basically now this 60 becomes the part. Okay. Of the base, which is 120. So when you will do this, 60 divided by 120 and you will try to find the percentage. Okay. 2 6 are, 2 5s are, 6 1s are, 6 10s are, 50% will be the answer. So I am solving the sum also and I am explaining you the value, the parts, the variables, the percentage, the part and the base. Okay. Now increase, decrease in percentages and discounts. Okay. Where do we use these percentages in order to find the increase in the profit, decrease in the price, okay, etc. Now say like 25% I got off on the MRP of a product. I went to shop a bag and I got 25% off on that. So if the bag was say of 2500 and I got a 20% of reduction discount off, then 10% hike in the price of diesel. If I want to find the increase or decrease in percentages and in discounts. Now see this. For example, the price of a laptop was 40,000 rupees last year, and then they have increased the price by 25% this year. So what will be the new price? So first I'll have to find 25% of 40,000. That is 25 upon 100 into 40,000. So 25 into 4 is 100, and the balance 2 zeros I'll put here. So by 10,000 the price has increased of this laptop. So the new price will be 40 plus 10. In the MCQ they might give you this 10,000 also as an answer. So don't tick on that. Don't attempt that 10,000. Attempt 50. Why? Because they are asking you now the new price of the laptop. They are not asking you only the increased price. They are telling you it is increased by 25%. So now what is the new price? So for us it is important to find the new price. Okay. Now see this next one. A toy which was marked at 1000 is sold for 920. Means it is sold by it is sold for 80 rupees less. What is the discount amount and what is the percentage of discount? Discount amount very easy. 1000 minus 920, 80 rupees is the discount. How will I find the percentage? Percentage I will always take value upon the base. Base will be your price, actual price. Okay. Into 100. 8%. All the zeros I cancelled it. 8% is the discount rate. Okay, 8%. Next question. The market price of the keyboard is 300. Market price. Okay, market price, mark price. And a discount of 15% is announced on the sales. What is the amount of discount on it and what will be its sales price? Actual market price is 300, but I am giving it on discount. So my selling price will change, right? What is the discount? 15% of 300. So 15 into 3 is nothing but 45. 45 rupees I am getting discount. Therefore, my sale price will be market price minus the discount. Market price is 300, discount was 45. So my price is going to be 255. You can solve it in the way they have also given. Okay, 15% of discount on 100 is 15 rupees. So for 300 it is going to be 45 rupees. This is really a long method. Simple. I want to find 15% discount on 300. I got 45. From that 300 I'll minus that discount. So my selling price of that particular keyboard is now 255. Clear? Okay. Then sometimes there are certain estimation in percentages. Now this is not actually estimation. See, I'll explain you this sum and in a very easy way. Let's say the total bill of a restaurant was 919.78. So I'll just round this about to 920. Here also it is given. And the restaurant has given a discount of 15%. How would we estimate the amount to be paid? Okay, we have to estimate the amount which we have to pay. Now this is a little, they have given it in a very little tricky way, but see how I am solving. Okay, the total bill is of 920. Okay, so basically this is going to include the discount. Okay, it is going to include the discount of 15%. So I can say this is 115. Okay, so 100 is going to be how much? So 920 into 100 divide by 115 if you will do. you are going to get it somewhere approximately as 800. Now this, the answer is a little bit of different, okay, because I have rounded off also and they have solved it in a very different manner. Okay, I can explain you all this as well. 10% of your 920, okay, 10% will be 92 rupees, and half of 92 then they have given, and then they've added 138. So getting onto an answer like this is not going to help us. Okay, I need to know how much I am going to kind of pay. So on 920, or I can say 920 directly into, see, I'll show you a better easy way. So the total bill is 920, and the restaurant has this, that they give a discount of 15% on the bills. Okay, so how much am I going to kind of, the amount, how much am I going to pay? So even if you all will do 920 into 15%, okay, 920 into 15% means 15 upon 100. When you are going to solve this, you are going to get 138 as the answer. So this will be your discount amount. So same thing, if I'm getting this as a discount amount, okay, so how much am I going to pay now? From 920, I will subtract this discount and I'm going to pay 782 to the restaurant. Okay, so basically now this 782 is after deducting that 15%. Okay, so they might ask you some, now they could have asked you this question, that 782 they have given you. They are telling you to find the actual price of the bill. Okay, so then also it is, you can solve it in this manner, in the same way. Okay, they can ask you a question wherein they have already given you the discounted price and then they are asking you the base price. Okay, so same thing, 15% on 920, if you'll do 138, so there is no need of doing this 10 by 100. This is given by the module. Okay, I put here for you all to see. Now percentage, you can also, you can also represent, see, percentage sign we know, but they can be converted into fractions and decimals. So if I'm talking about 10%, every time I was writing, right, 10 upon 100, 20% will be 20 upon 100. Okay, if I want to convert this as a fraction, it will be 1/10 of the fraction. This will be 1/5 of the fraction. Okay, to the simplest form. 2 1s are 2, 5s are 10, na? So when I'm converting it into the simplest form, similarly 25% will be 1/4, 50 will be half, 75% will be 3/4, and 90% is 9 by 10. Okay, so there can be percentage in case of decimals also. Okay, 0.33%, 1.88%, 0.90%. Okay, so there can be percentage even in case of decimals. Now let's solve some simple examples and sample questions. If 20% of 30% of a number is 8, find the number. Now see, this is something similar to any kind of a tricky question like how they ask for the restaurant. In fact, that was much simpler. 15% on 920 you did, you got the discount, you found the price paid. They are saying 20% of 30% of a number is 8, find the number. So let the required number be x. They are saying 20% of means 30%, of means multiplication, of this number x is equal to 8. I can write 20% as 20 upon 100. This will be 30 upon 100. X is equal to 8. Okay. Now, okay, I'm going to take this 100 sign on the other side. Okay, basically I can directly also solve, but I will just show you all stepwise so that you all don't get confused. So I will say 20 into 30 x, okay, is equal to 8 into 100 into 100. I have taken these denominators on the other side, so it will become numerator, right? So this is going to become 60x, 8 into 100 into 100. So x will be equal, no sorry, not 60x, 600x. 20 into 30 is going to be 600x. So x will be 8 into 100 into 100 upon 600. Okay, 2 3s are 2 4s are. So you have to 400 divide by 3. When you will solve this, you will get the answer in decimal form, which is 133.33. Okay. Next question is very easy. Which number is 30% less than 75? Okay. I have to less 30% from 75. So basically they are asking me 70% of 75. 75 into 70%. Okay. They are asking me this. 30% less than 75. You can find 30% of 75 and then subtract whatever answer you are getting from 75. Or directly you can do 70% of 75. So your answer will come in decimals when you will solve. 52.5 is 30% less than 75. Next question. The sum of 12% of 28 and 5% of 175 is equal to what value? So basically you will do 12% of 28. When you will solve this, 12% means you are going to do 12 upon 100 into 28. And sum means addition, and then you are going to 5% of 175. So 12% of 128, you will get it in points, 3.36. You have to solve it properly. Okay. You can divide this and make it into the simplest form. Or you can just put it as 0. When you are dividing 12 upon 100. Okay. So 2 decimals, 1 and 2. 0.12 into 28. Same thing you can do here, 0.05 into 175. So it will become easy. Okay, so if I am saying 175 into 5%, I am going to get 8.75. So they are asking me to add both 3.36 plus 8.75, 12.11. But you will have to properly solve it. Okay, you can't use the calci. They might not give you something like this because there is no usage of calci allowed. But this is something very easy to multiply and solve. Okay. Get it to the simplest form and then solve it. A stationery seller had some registers. He sells 40% registers and still he has got 420 registers. Originally, how many registers he had? So now they are asking you the total value. They have given you the other values and now they are asking you the total value. He sells 40% of the registers. Okay. So let the number of registers be X or let it be N. Okay. So 40% he has sold. So out of the total number, he has already sold 40%. And now he is left with 420. Okay. So basically I can say X minus 40% of X is nothing but 0.40x is equal to 420. I am solving it in much simpler form. 1x minus 0.4x will be 0.6x 420. X will be equal to 420 upon 0.6. Okay. Now in order to convert this 0.6, you can convert this 0.6 by multiplying it, you have to do a multiplication over here then. Multiply this by also 10 and then on this also by 10. So 4200 upon 60. No, 4200 upon 6, not 60. Upon 6. So you will get the answer as 700. So total registers were 700. Okay. What they have done is also very simple. Since you have sold 40%. So assuming total as 100%. From 100% if I am selling 40%. I am left with 60% of X. That will become 420. Even this is very easy. So X will be equal to 60% means what? 60 upon 100. Okay. Is 420. So X will be nothing but 420 into 100 upon 60. This also will give you 700 as the answer. Even this is very easy. Out of two numbers, 20% of the greater number is equal to 50% of the smaller number. If the sum of the numbers is 140, then then the greater number is what? Okay. 20% of the greater number is equal to 50% of the smaller number. Okay. So if I say greater number is X and smaller number is Y. Okay. Out of the two numbers, if the sum of the numbers is 140, okay, and sum of these two numbers is also they have given me 140. 20% of the greater number is equal to 50% of the smaller number. So I can say 20 percentage and percentage sign both in the opposite, you can cancel it. 20x is equal to 50y. Okay, so if I want to write this x, I am just converting one equation. I'll write 50 upon 20y. So x will be equal to 5 upon 2y. I got this one equation and this is my second equation. So if I'm submitting this 2, okay, I'm putting it in my first equation. So instead of x, I'll write 5 upon 2 y plus y is equal to 140. I have to make the denominator same in order to do the addition in the numerator. So even this I will have to multiply by 2. This also have to multiply by 2. So this will become 2y. The whole thing upon 2 is equal to 140. So 7y will equal to 140 into 2. So y can be written as 140 into 2 divided by 7. 7 ones are 7, 20s are 140. So y is equal to 40. Smaller number is 40. Therefore, greater number will be 140 minus 40. That is going to be 100. See, the sum is 140. Out of that, one number is 40. So the greater number is going to be 100. Clear? Okay, you all can copy this sum. I have simple done it. I have assumed the two numbers. One is x, one is y. They have given me one equation. The sum is 140. Second equation I derived it. Since they said 20% of x is equal to 50% of y, I solved x to be in the value of y. X is nothing but 5 by 2 of y. Substitute this equation 2 in your first equation and solve it. You will get the smaller number. From the sum, subtract the smaller number, you will get the larger number, the greater number. Okay. So this is it with your percentage. In percentage, what is important is the percentage sign, then the part and the base. Okay. So these type of sums can be asked in your MCQs for percentage. Okay. Thank you everyone. Bye. Hi everyone. Come on. Now we are going to begin with the third topic, which is ratio and proportion. Third topic of our fundamental arithmetic operations, quantitative aptitude. This is your other chapter of quantitative aptitude. Okay, so the moment you solve all these topics and the first chapter, number systems, 20 marks of quantitative aptitude, you cannot go wrong anywhere, right? So beginning with ratio and proportion. Ratio and proportion means what? That if I have say if there is, like for an example where I put this image, that there are 3 dogs and 2 cats, okay, in a given vicinity, what is the ratio of the dogs to cats? So it is 3:2 here they have given. Similarly, if there are 12 boys in the class and there are 8 girls in the class, okay, so the ratio is 12:8. You can simplify the ratio. So ratio and proportion basically gives you the fraction from the whole. Like how in percentage you try to find the value from a base. In ratio and proportion we try to get the fraction. Say out of the pizza there are 4 slices. Okay, 1 is eaten. So how many are remaining? 3/4. Right. So ratio and proportion is very, very important. It is one of the fundamental bases, for doing your management accounting. So all these basics are taught to you all, because when you all will come in CS Executive, you have these chapters in detail. Okay, so you will be doing ratios in accounting. So you have to know how much was the ratio of your profit or of your goods or of your loss, of your debtors, creditors, everything. So you're comparing 2 variables together. It is very important to know the ratio. Okay. So generally whenever we don't denote the ratio, we write it like this: x is to y. Okay. And you can also write it as this numerator and denominator. Okay. Where the denominator is basically not a 0. So coming to the basic important way, okay, direct proportion and inverse proportion, which is very, very important. Okay, this is important. Ratio proportion theory you all can read, but this is what is important. Direct proportion means what? That there are 2 variables directly related to each other. Okay, so if I will increase the speed, the distance I will travel will also increase. Directly related. Okay, and inversely related means what? That they are, if you increase one, the other is about to decrease. If we drink more water from the bottle, here they have given, so amount of water will be left in the bottle will keep on decreasing, right? So when there is an inverse relationship, where there is one increase in the variable and one there is a decrease in the variable, and there is a direct proportional relationship when both the variables are either increasing or decreasing. Okay. Now ratio and proportion formula, as I told you, we generally solve this. We write the ratio proportion as x is to y, where you can then write this x upon y. X is known as the antecedent of the first term and y is the consequent of the or you can write as a second term, first term and second term. Okay, in order to write the proportion in mathematics for 2 ratios, okay, you are saying a is to b and you are also saying y is to z, and we want to express this, okay, a is to b is equal to y is to z. So the 2 numbers, which is b and y, they are known as mean terms, and a and z are known as the extreme terms. Okay, so generally in this type of ratio proportion, we do, see now, a is to b is nothing but a upon b equal to y upon z. So if I will try to solve this, it is cross multiplication. A into z extremes will be equal to the mean terms. Okay, but these type of ratios can be used when you are comparing like the similar, there has to be a similar unit. So if I am trying to compare kgs with meters or kgs with speed, no, it has to be the same unit. So 10 meters, 10 is to 20 meters is equal to 50 kg is to 100 kg. Okay, in the same similar units I can do it. I cannot take it kgs with the speed or time, etc. Meters and kgs, okay. Okay, milliliters, liters, etc. Okay. Same in the same units it is there. So if I give you two ratios, okay, and I try to find and I ask you to find the answer, so you will be multiplying the two means with the two extremes. Okay, so if the ratio, they have given you proportion of the ratio as 5:10, always it is written that is equal to 10:20. Simple, you will take 10 into 10. Okay, the medium means into extreme means. 10 into 10 is nothing but 100, and 5 twos are 20. No, this is last one is 20. 5 into 20 is also 100. Okay. Now difference between, what is the difference between ratio and proportion? Generally they are similar. Students occasionally struggle to understand what is the difference between ratio and proportion, but actually there is not much difference. Okay. Ratio are any numbers or parameters, okay, which is comparable with others. When two ratios are written in the same manner, there is a proportional relationship. So you can have a proportional relationship between two ratios. Now sample questions on ratio and proportion, we will move to that fast. Why? Because it is very, very easy. Now say this, there are 63 students in the 8th class. The number of students who want to study Sanskrit and the number of students who want to study mathematics is expressed in the ratio of 5:2. Calculate the number of students who want to study Sanskrit and the number who want to study mathematics. So they have given you the total number of students and they have given the ratio of students who want to study a given subject. Okay, so in the class, in the 8th class, there are 63 students and we know the ratio of Sanskrit is to maths. Sanskrit is to maths is nothing but 5:2. Okay. So let the number of students who want to study Sanskrit be 5x. Therefore, the one who wants to study mathematics will be x. So basically, I can say 5x plus 2x will give me 63 total. I'll have to find the value of x first. Okay, so 7x is equal to 63. Therefore, x will be equal to 9. Now I got the value of x. I will put this value into 5. 5 into 9 will be 45. This will be the number of students who want to do Sanskrit. And then I will put 2 into 9, which is 18. 18 students want to study mathematics. When I will add 18 and 45, I am going to get the answer as 63, which is the total number of students in the class. Clear? Okay. Next question. R and S, they have started an electronic shop and decided to divide the profit. Now see where all it is useful. There is a profit ratio between them. R is going to take 7 parts of that profit. Say there is 100 rupees profit. 70 he is going to take. 5 he is going to take. Okay. Like you have to find it in the form of ratio. So if I am telling you 7:5 is the profit, 7 belongs to R and 5 belongs to S. And the total profit they have given me is 12,000. They are telling me to find the profit for each one. Simple. Okay, what is the total of the ratio? It is 12. Okay, out of the total, 7 parts is taken by S, R and 5 parts is taken by S. So for R, I will find the ratio as 7 upon 12 into 12,000. Okay, 12 ones are 12, thousands are. So this is going to be 7,000. And for S, he is going to take 5 of the total, means of total 12 into 12,000. This is going to be 5,000. So here we can find the profit, also the division of profit from the total profit which is there. Okay. Now if Abhishek is traveling a distance of 25 kilometers in 5 hours, how much distance can he travel in the time of 8 hours? Okay, so hours and hours is given. We have to find the kilometers. So one ratio is that if it is 5:8 hours, okay, he's for 5 hours he's covering 25 kilometers. So in 8 hours is he going to cover how much? Say x. So I'm going to multiply the medium, means 25 into 8 will be equal to 5 into x, and the extreme means, okay, so I'll say 25 into 8 upon 5 will be x. 5 ones are 5 5s are 25, 5 8s are 40. So he is going to travel a distance of 40 kilometers in how many hours? In 8 hours. 8 hours. Okay, 40 kilometers in 8 hours. Next question. Calculate the number whose sum is 88. Okay, and they are written in the ratio of 4:4. Okay, let us consider the number is to be 4x and 4x respectively. Okay, or let the number be x. Simple, let the number be x, like how we did for the previous sum. Okay, let the number be x. So 4x plus, the ratio is written as 4:4, na? So 4x plus 4x is equal to 88. They are saying the sum is 88 of these numbers. That means 8x is equal to 88. So x is equal to 11. So each number, the two numbers are 44. 44 and 44. Because it is in the same ratio also, no? So it has to be the same number. 4:4. Okay. So this is it with the ratio and proportion. There is nothing much for ratio and proportion. Even if you will solve these sums, it is much more than enough to know in the ratio and proportion. Okay. So remember that in the ratio and proportion you can have the comparison of the similar units. Okay. It gives you the proportion of the two different ratios. You can find the profit, the number of students in the class, etc. with the help of this ratio proportion. Okay. Thank you everyone. Bye. Okay. Hi everyone. So we are going to begin with the next part, which is square roots. Okay. Square roots and squares. Basically, if I am telling you to find the square of a given number, it is the meaning means that you multiply that number with the number itself again. 2 times you multiplying that number. So if I am telling you to find the square of 4, you are going to multiply 4 by 4. So square root is basically, if I am telling you to find the square root of 4, you know that it is nothing but 2. Okay, when I write the square root, I have to bring that number, I have to divide that number in a form, I will get only a single digit. Square root of 4, I got it only when did I get the square root of 4? 2 into 2. I got a square of 4 when I did 2 into 2. So square root of 4 will be also 2. Same number I am multiplying by itself. So there are numbers which are perfect squares. So 1 into 1, 2 into 2, 3 into 3. There are numbers which are perfect squares. So when you have numbers like 1, 4, 9, 16, 25, 36, 49, you know that these are perfect squares. 121, 144, 169, so hence and so forth. Many numbers. Okay, so these are all perfect squares. Now square root is, whenever I am asking you to write a square root, when an integer is multiplied by itself, the result is known as the square root. That means the result of the number multiplying itself is referred to as the square number. The symbol for square root, we write it as this. So if I am telling you square root of 4, you know 4 is a perfect square. It is a square of 2. Square root of 9. 9 is also perfect square. It is a square of 3. Okay, 3 square is giving you 3 into 3, 9. Okay, so whenever I want to remove the square root from here, So I'll write 9 will be 3 square. Square root, when you remove from one side and you put it on the other side, it becomes a square. Okay. Now to find the square root, there are these two important methods only. Other estimational method and all that, there is no time to sit and think and do trial and error in estimation method. Okay. Prime factorization and long division method. Any number they give you, you try to see that whether you can solve it with the help of prime factorization. If not, then you go by the long division method. Both the methods are very easy. Prime factorization, we can use it when the number is only up till 3 digits. Okay. For long division method, 4 digits numbers have been given to us. We will use long division method. Okay. In prime factorization, how do you solve a prime factorization sum? Now see this, 196. So I have to find the square root, okay, of 196. Let us find the square root of 196 by prime factorization method. Simple, just make one line, division line here. Okay. One line over here. Now start with any of the prime numbers. Prime factorization means what? We are talking about the prime numbers 2, 3, 5, 7. Okay. All those prime numbers, 9. Okay. So start with any of the number. So say I am starting with 2. I know this is good. 6 goes in 2, no? So 2, how much are 19? There is no number like 19 for in the 2's table. 2 9s are 18. 2 8s are 16. Again I can divide this 98 by 2. 2 4s are 8. 2 9s are 18. 49 goes in the table of 7 directly. 7 7s are and 7 1s are. So I will keep doing this until I get 1 down last. So I have prime factorized this 196 as 2 into 2 into 7 into 7. So I'll take the pair. 2 and 2 is 1 pair, 7 and 7 1 pair. So write 2 ones and 7 ones. 7 twos are 14. 14 is the square root answer. You know, the square root of 196 is nothing but 14. You can check it. Multiply 14 by 14. You will get the answer as 196. Okay. So this is prime factorization method. One more sum I will solve. 625. Okay. By prime factorization method. I know 5 is divisible by 5. 5 is the prime number. Correct? Okay. So I can do it by 5. 5 ones are 5. 5 twos are 10. 5 fives are 25. Again by 5 I can divide. 5 twos are 10. 5 fives are 25. Again by 5. 5 fives are 25. And then again 5 ones are 5. So I have got 5 into 5 into 5 into 5. I'll pair these numbers. 5, I'll take it once. From this 2 5s also I'll take it once. 2 pairs. Two numbers in the same pair. So this is 25. So the square root of 625 is nothing but 25. So when you will do 25 into 25, you are going to get the answer as 625. Okay. Now similarly we can use long division method to find the square root. Okay. So finding the square roots that are not perfect squares is also very challenging. So we generally try to use a long division method. Okay. When there are numbers which are big numbers, then we try to use the long division method. Now how do we solve these type of sums? I am going to solve 8281 first. Okay. So let's begin here. Okay. 8281. I have to find the square root of this number. by long division method. I will first make one line on the vertical side and one on the above the number. Okay, simple, easy. Once I have finished making the lines, the next step is to pair the numbers. Okay, so I will start pairing the numbers from the one side. Okay, from ones I will start pairing. So this will become my first pair and then this will be my second pair. So I've got two pairs of this number, this whole number. Now I will first work on the first pair, 82. I'll try to find that number which is close to the square, okay, of a given number, which gives you 82. So say if I do 7 into 7, it will give me 49. Okay, if I will do 8 into 8, it will give me 64. 9 into 9, I'm just doing that. 9 into 9, it is going to give me 81. So 81 is the closest with 82. Right? I have to find a number with whose square I am going to get a number which is closer to this number, first pair. So if I am writing 9 here, I will multiply it by 9 and I'll write it over here and get the answer as 81. Same number with which I have multiplied, I will write that number down also for adding it. I will multiply from above and add it below. Okay. So when I add 9 with 9, I'll get answer as 18. The sum is 18. And 9 into 9, I got 81. Now I'm left with 1. From 82, I subtracted 81. I'm left with 1. And here I have now brought down the second pair. 81, I have got it down. Now make a box. Over here also make a box. And over here also make a box. We have to multiply. Okay, we have to find such a number in the box which will be same. So if I am writing 1 here, in this also box I have to write 1. If I am writing 2 here, also have to write 2 only. Same number. I cannot change the number of the box. The number in that box. Same number has to be written. I have to get it in such a way that I get the product as 181, which I want here. So only then the answer will come 0, no, down. Right. So basically if I will say 181 into 1. So 1 ones are 1 8s are 1 8s are 181. So if I am writing 1 over here, I am going to write 1 also here. So 181, I will get 0. Here I will do plus 1, I will get 182. Okay, here it is 182. The answer is over here. 91 square will give you 8281. Multiply 91 by 91 and see. You will get this answer. 91 into 91. Let's do it. 1 ones are 1. 1 nines are 9. 9 ones are 9. 9 nines are 81. Okay. Add it. 1 plus 0 is 1. 9 plus 9 is 18. 1 plus 1 is 2. And this 8281 is the answer. So even long division method is simple. Whatever I will multiply on top, I will add down. It has to be a square. Okay, a perfect square closer to that given pair. We will solve one more sum. 6084. Okay, let's solve this. 6084. I'll start pairing the numbers from the unit side. So I have two pairs. I will make the line above. Sorry. Okay, now I'll try to multiply the number in such a manner wherein I will get a closer number, square of a number which is closer to 60. So I have 7 sevens are 49. I have 8 8s are 64. So I'll have to do it with 7. Okay. So if I'm writing 7 here, I will write 7 for multiplication over here and for 7 down also for addition. 7 sevens are 49 minus, so I'm going to get this as 1 1 and I'm going to bring the other pair down. Since I have multiplied by 7, down also I'll add by 7, I'll get 7 plus 7 14. Now I'll make a box here and I'll make a box here. I'll have to use such a number which will fit in both the boxes, same number. If it is 2 2, 3 3, 4 4, I cannot change the number. I have to fit it in such a manner that I'll get the answer as 1184. So let's try. If I'm doing 140 some number here, I'll multiply by which number? I can get the answer as 84. So if I'm doing 2 2s are 4, I'll try to see what is there in one's place. Some type of logical thinking I'll do, because 2 into 2 only can give me 4. 3 into 3 if I'll do, it will not give me 4. 4 into 4 will give me 16. That will also not help me. Okay. 5 5s are 25. That will also not help me. So I'm trying to do it by 2. So 2 2s are 4. 4 2s are 8. 2 1s are 2. I'll get the answer as 284. It is very, very less. I want 1184. So what is the other option I'm left with, wherein I will get a 4 below? 8 8s are 64. So now multiply this and see. 8 8s are 64. So 6 carried forward 4 here. 8 4s are 32. 32 plus 6 will give you 38. 8 here, 3 above. 8 1s are 8. 8 plus 3 is 11. So 148. So 8 is the number. So I will put 8 over here and I'll put 8 here. Correct? So 1184, I'll get this as 0. So here also I do an addition of 8, it will become 156. And the answer is 78. Square will give me 1184. Therefore, square root of 1184, 6084. 6084. Square root of 6084 is nothing but 78. Clear? Long division method. Okay. So properties of square root, let's go there. Only a perfect square number can have a perfect square root. Obviously 2 2s are 4. So 4 can have a perfect square root. Even a even perfect square has an even square root. Square root of an odd perfect square will be odd. Because a perfect square cannot be negative, it is impossible to define the square root of a negative number. A square root can be found for any number if the units, the digits in the unit is ending by 1, by 4, by 5, 6, 9, only then. Okay. It is impossible to find the perfect square root if the units digit is ending by 2, 7, 3, 8. It cannot be found. A number cannot have a square root if it has an odd number of zeros at the end. Only an even number of zeros can have a calculation of square root. So if I am having it 2 zeros after the number, yeah, it is possible to have the perfect square. But if I am having 3 zeros, it is not possible to have a perfect square. Okay. Square root formula, we have already discussed it. Square root of a negative number. So if I am finding the square root of minus 16, okay, so I cannot write it like this. So it is basically, I'll write the square root of 16, which is 4, and then where I will write I. I means it is minus. Okay. I is represented as a square root of minus 1. I'll have to separate this. Okay. Square root of minus 1, I'll write it as I. And square root of 16, I will write it as 4. So the answer of this type of negative square root will be 4i. Come on. Sample questions. Which of the following figures is a square in all its parts? On all its parts means it is a perfect square they are asking. So you can use prime factorization method and also you can find out. Okay, so actually you can see this. If you want, you can use prime factorization method. Okay, it actually will not be a perfect square. Okay, so you can say 11 ones are 11 and here it will be 0. 11 ones are 11 and then you will carry forward this one. So here there will be certain points. 225 we can try because the number is ending by 5. So this we can try. So we have 5 4s are 20, 5 5s are 25, then 5 9s are, 3 3s are, 3 1s are. So 5 into 3, 15 will be the square root of what means 225 is the perfect square root of number 15. 15 into 15 will give you 225. You can try it for 142 also, you can try for 156, but they are not the perfect squares. A perfect square number can never have the digit dash in its units place. It can have 1, it can have 4 because 1 is also a perfect square, 4 is a perfect square, 9 is a perfect square, 8 is not a perfect square in itself. So you can never have this in the units place. If you have 8 in units place, that means it is not a perfect square number. Evaluate square root of 6241. So you can do this with the help of the long division method. Okay, so you can solve this as a homework. Try to see the sums which I have solved. You will definitely get the answer. And even find the square root of 6724. This also you can do it by long division method. Okay, there are 4 digits, no? So use long division method to find the square root. See, here also you can do it with the help of the long division. Very big this is. It will be having 3. See, here it will be like there will be many pairs. 1 4 9 8 1 7 6. So there is this one pair, then this one pair, and then in the last you take the all 3 together. Okay, so even this you can solve it with the help of long division method. Okay, so these are the sums which is there for square root. Okay, this is all what there is no cube root for you all, there is only square root in the syllabus. Okay, so 2 methods which you all have to focus on. One is prime factorization and the long division method. Both I have solved with you all. So both you can keep this table in front of you and then solve it with the help of the long division method. It will become easy. Okay, so this is it with the square root. Thank you everyone. So hello everyone. So let's begin with our next topic, which is averages. Okay, again part of your fundamental arithmetical operations. Alright. So now average is basically when they have given you certain set of numbers and they are trying to ask you to find the average of that number. So if I am telling you that there is a group of 5 girls and their height is so and so, so find the average height. Or if I tell you there is a profit of rupees 1000 every year, or say 1000 in 1 year, 2000 in another year and 3000 in another year, what will be the average of the profit? So you will add all and divide by 3, the number of elements which are there to be added. Okay, so I can say 6000 divided by 3, on an average I am making a profit of 2000 per year. Okay, so average is a single number basically used to represent the whole set. Okay, represent a group of numbers. This average is the arithmetic mean. It is known as an arithmetic mean, which is the total of all the numbers divided by the numbers of numbers in the group. So if I am telling you find the average of 2, 3, 4, 7 and 9. So you will first add all of them. Okay, you will add 2 plus 3 plus 4 plus 7 plus 9, which is 25. And how many numbers are there? 1, 2, 3, 4 and 5. You will divide that by 5. You will get 5 as the answer, which is the average of these numbers, average of the values. So the formula for average is nothing but the sum of values divided by the number of values for which you did the sum. Okay, it is known as average or it is known as mean. Okay, so we will have to understand it with some examples. Okay, so the steps is first you will find the sum of all the numbers that we have understood. Then you will see number of observations are there, and then you will divide that sum with the observations. Okay, so now let us consider one example. There is a group of numbers 19, 25, 29, 21, 22. So you will add all the values first. Okay, so you will do 19 plus 25 plus 29 plus 21 plus 22. Divide this all by number of values. How many values are there? 5. You will get an answer as 23.20. See here, it is solved for you all. 116 divided by 5. So this is known as average. It is known as the arithmetic mean. Okay, where n is the number of observations, I represents the index of the summation. Okay, total summation. Okay, and ai is the data value of the given index. So you just need to know that you need to add all and divide that by the number of observations given. So let's calculate. So if they tell you find the arithmetic mean of a given number, that means they're telling you to do the average. So they have given me these numbers, 5 numbers, 5, 8, 12, 15 and 20. When I add them, it comes to 60. 60 divided by 5, 12 is the average, the mean. Average of negative numbers. Now in case of negative numbers, try to first get the answer. How we followed that BODMAS rules, that addition and subtraction, the properties of addition and subtraction. So see in this number 3 plus the number is minus 7. I told you we have to add all the numbers. So I am adding only wherever there is a negative sign, I am putting that number in the bracket. Okay, so first solve this. So when I will remove 3, means I will remove 7 from the bracket, the plus will become minus. Minus and plus is always minus. This will remain same. 12 will also remain same. Plus and minus again minus, it will come out. Right? Now when I will solve this, it will be 3. You can do it slowly. 3 minus 7. 8 plus 12. First do the addition. It is 20. Minus 2. Then 3 plus 20. Minus 7. Minus 2. 3 plus 20, 23, minus 7, minus 2. Okay, so when you will do this, 23, so I put this bracket. Okay, 1 minute. So 3 plus 20 will be 23. Okay, then from 23 I will subtract 7. Okay, so when I'll subtract 7 from 23, I have to remove 7 from there. So I'm going to get 16 positive number minus 2. 1 positive, 1 negative, I am going to always find the difference. So 14 and sign of the greater number. So answer is 14. This 14 I will have to divide by number of observations. So 1, 2, 3, 4 and 5. 5 observations. Answer will be 2.8. It is in decimals. Average is 2.8. Okay, now solved example. Same thing, find the average of 73898. So first add 7 plus 3 plus 8 plus 9 plus 8. I am going to get 35. 35 divided by number of total units 5. Answer is 35 divided by 5, 7. Find the average of 11, 13, 19, 22 and 10. When I'll add all the numbers, answer is 75 total. Number of observations is 5. So the 75 divided by 5 will give me 15. Average is 15. If the age of 9 boys, there are 9 boys in a team and their age is given 12, 13, 11, 12, 13, 12, 11, 12. So almost they are around the same age. I have to find the average age of all the boys. So I know there are 9 boys. I will add all the observations. 12 plus 13 plus 11 plus 12 plus again 13 plus 12 plus 11 plus 12 plus 12. I'll do this and I'll divide that by 9. Sum of all the ages divide by total number of students. I'm getting 108 upon 9. So average age is 12 of the boys in the team. See, now they have given, if the heights of the female in the group, it is given in 5.1, 5.2, 6, 4, 9. They have given all the females. So how many females are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so you will add them all and divide that by 10. So the sum when you add, it is 54.9 divided by 10. It will come as 5.4. Just take 1 point here. Okay, so the average is 5.49. Okay, so these are the questions for your average. Okay, average is the simplest of all the topics. They are going to give you the number, the different numbers, the set of numbers, and they are going to ask you either find the arithmetic mean or find the average. In case of negative numbers, you will follow this rule. Okay, like how we have done here. Slowly open the brackets, then solve the positive ones and then subtraction. Okay. So this was it with the averages. Thank you everyone. Bye. Okay. So now we are going to begin with interest related topic. Okay. It is the second last topic. Now after this you have just got profit and loss. Very easy. Simple interest and compound interest also from your exam point of view in CSEET. Generally they will ask you questions more of simple interest. Compound interest, if they ask, it will be compounded either annually or half yearly. Not more than that, because you are supposed to solve it manually and not use your calci. Okay. So just to give you a understanding that simple interest, even if in case you all have not heard before, if say I am taking a loan of rupees 100 and there is an interest which I have to pay on 100 at 10% per annum every year. So I will say, since we did percentage, 10% of 100 rupees is going to be 10 rupees. So I have to pay 10 rupees extra on this loan. Say if I have taken an investment, I have done an investment of 100 rupees in the bank and I am getting 10% interest from bank. I am going to get 10 rupees yearly. So simple interest says what? That your principal, whatever is your principal, interest will always be calculated on your principal amount and you are going to get every year 10 rupees. So even if it is the first year 10 rupees, second year also 10 rupees. But in case of compound interest, this changes a little. What happens in compound interest? Your principal amount gets accumulated. So your 100 rupees was your principal amount. First year you got interest of 10 rupees. Okay. So when you got the interest of 10 rupees, now your principal has become 110. So next year when you will get interest, you will get it 10% on 110. Okay, so now you are going to get 11 rupees. Then the third year 110 plus 11 will be your principal. 121. Okay, so on 121 then there will be more 10%. So here in compound interest, the principal amount keeps on getting accumulated with the interest, and interest is calculated on that accumulated amount. Okay, so see, simple interest. Interest on principal only. Interest is on principal only. So say $200 are invested at the rate of 3% for 2 years. In first year also you are going to get 3% on 200, which is $6. Second year also $6. So total you will receive 12. But in case of compound interest, interest on principal as well as interest previously earned. So same sum, $200 are invested at 3% for 2 years. So first year I will get $6. Why? Because 3% of 200 is 6. But next year I am going to get interest on 206 rupees. Okay, $206 into 3%, that is going to be 608, 6.18. 6.18 plus 6, so 12.8. 12.18. So I'm going to get 0.18 of dollars more if I do a compounding interest, okay, policy. Okay, whatever it is, if I'm doing a compounding interest, I'm going to get more return because my principal keeps on increasing. Okay, so interest is nothing. The maxim that one should never borrow money for free should be kept in mind all the times. Okay, borrowing money is very expensive. Therefore, interest is something you pay over and above your principal. Okay. The meaning and definition of interest. So say for instance, a borrower might take a loan of 10,000 and then they agree to pay additional 100 rupees as an interest. So what is the rate of interest on 100 rupees I am paying additional on 10,000? Okay, I have to find this in the form of percentage. Okay, so it is going to be 1%. Right, I am paying 100 rupees on 10,000. Okay, the interest rate for instance would be 10% if the prior borrower were agreed for the full year. So 100 rupees interest on 10,000, okay, is just 1%. If it would be 10% of 10,000, it will be 1,000 rupees. Okay. Now, type of interest rates, simple interest or compound interest. Compounding means interest can be computed weekly. You can compute it monthly, half yearly, quarterly, okay, annually, etc. There is a formula how to find it. So we will see in executive level, simple interest, compound interest is like a full chapter in itself. Okay, you have to know the entire value of your money in some years down the line if you are investing or borrowing, etc., whatever you are doing. Okay, now how does this interest work? There are various methods for calculating interest. Some are advantages for the lender. So if I'm lending money, I will see it in a different way. I'm borrowing money, I'll see it in a different way. So when one borrows, they are required to pay back. So one must pay back more than they originally borrowed plus interest in order to make up for the lender's risk. I'll pay more for the amount borrowed. And when lending money, if someone has extra money and lending you, so obviously if I'm lending you money, I would want to make some more money out of what investment I did in you, right? So rate of interest, amount of loan, how does it take to repay loans, all these are the factors on what amount of interest depends upon. Okay, so say if your basic interest formula to determine your interest amount, and interest charge of rupees 500 is applied on 5,000. So the annual interest will become 10% because 500 rupees of 5,000, if you calculate in the percentage form, okay, it is 5 ones are 5 tens are 10% is the rate of interest. Okay, now formula. How to calculate the interest with the help of two formulas. One is simple interest formula, one is compound interest formula. Simple interest is very easy. For simple interest, you need three things: principal amount, rate of interest, and the time, number of years or months, etc. whatever. Okay. So 1 year, 2 year, 3 months, 6 months. Okay. You need the time. Okay. So this is what you need for simple interest. Divide that by 100. It can happen that they have given you simple interest and asking you to find the principal or rate of interest or time. Okay, this also can be a possibility. One of the variable will not be given to you. Okay, so now let's see. We'll see the sum. An invested sum fetched a total interest of 10,000. The rate was 10% in 1 year. What is the principal amount? So basically they have given me the simple interest amount. Principal into R into T upon 100. Simple interest is 10,000. Okay, I am taking this 100 also up. Principal I don't know. Rate of interest is 10. Okay, and T is 1 year. Now don't write 10 again upon 100. You have already done this here. This below this 100 is because of the rate of interest, which is, we write it in the percentage form, no? This percentage, when then we write it in the fraction form. So this 100 is already written. So now don't write 100 divided by 10 divided by 100 again. And number of years is 1. So 10,000 into 100 divided by 10 will be the principal amount. Okay, so 10,000 into 10 will be 1 lakh rupees. So original principal amount was 1 lakh rupees. Okay, so they can give you any one variable, or they can ask you to find any one variable amongst the others. Let's solve these two sums also. Principal amount is 800, interest is 5%, and the number of years is 2. So simple interest will be nothing but principal is 800, rate of interest is 5, number of years is 2. Okay, so 5 2s are 10, 10 into 8 is 80. So I am going to get 80 rupees in 2 years. Okay, on 800. Simple interest amount is 80. Now principal 2000, rate of interest is 7%, but it is only for 3 months. So here simple interest will be 2000 into 7%. 3 months means 3 divided by 12. Okay, 3 divided by 12. This you can simplify. 3 1s are, 3 4s are, 4 1s are, 4 5s are. So you will get the answer as 35. So if you are going to say invest 2000 rupees at 7% rate of interest for 3 months, you are going to get an interest of rupees 35 on that. Okay. So simple interest formula is done. Now compound interest. Compound interest, see this. They have given one example, very nice example. If John takes 4,000 per year at 10% interest rate, the interest for the first year will be 10% on 4,000, which is 400 rupees. But in the second year, now interest will be taken on 4,000 plus 400, that is 4,400, and then now on that you take 10%, you will get 440. So now you can't keep doing this if I am asking you for 4, 5, 6 years. So there is a formula for this, wherein amount to be accumulated after that number of years, okay, is nothing but the principal. The whole thing 1 plus R is the rate of interest. You do the rate of interest in decimal over here. N is the number of times the interest is compounded. And here N into T. Number of time interest is compounded. In T is the time the money is being invested or borrowed for in the number of years. Means 2 years, 3 years. T remains the same time. N is the compounding times. Okay, number of compounding times. Half yearly, yearly, quarterly, annually. Okay. So now let's see. Suppose you invest 1000 at an annual interest rate of 12%. Compounded annually. Okay, compounded annually means calculated annually. So after 1 year, you are going to get that interest added to the principal. Okay, simple. 1000 into 12%. You are going to get the amount. So that is for 1 year. You have to find this for 5 years. Correct? So now let's see. Put the formula. A is nothing but principal 1 plus r upon n, the whole thing raised to n into t. R we will always write it in the form of decimal. Okay. So 0.12. Compounded number of times, which is compounded only once. Annually means once. Compounded half yearly means twice it is getting calculated. Quarterly, 4 times it is getting calculated. Monthly, 12 times it is getting calculated, right? And getting added to your principal. But here it is compounded annually. Generally they will ask you annually only. Annually or maximum half yearly. Okay. Upon n into t, n we know it is 1, t is 5. All this is given. So first try to solve the bracket. Okay. When I solve this bracket, I will do 1 plus 0.12 upon 1 is same thing, no? So I am get 1.12, the whole thing raised to 5. So you have to multiply this 1.12 5 times. So you will have to do 1.12 into 1.12. Whatever answer you will get here, again 1.12. Again you will get some answer, again 1.12. So 5 times you have to multiply it. They might give you the value also of this. Okay, if this value is given, simply multiply by the amount, principal. You will get the accumulated amount. See, sometimes they give you the value. So value of 1.12 raised to 5 is 1.7623. So multiply 1000 by 1.7623. So you are going to get 1706.23. This is your 1762.32. This is your accumulated amount after that 5 years. Okay, so your interest amount will be how much? Your interest, if I tell you to find compound interest amount, only interest will be how much? 1762 minus 1000. So 762.32 is your interest amount. Totally you got in this 5 years. Okay. Now difference between simple interest and compound interest. Yes, of course. Since compound interest will fetch you better interest, because here the interest is added in the principal amount and then the interest is calculated for the next period. Now let's do some sample question on interest. Arpit takes an education loan of 15,000 from the bank and the loan period is 1 year. Rate of interest is 10%. Find the interest and the amount he will have to pay back at the end of the year. So we have got the principal 15,000. Rate of interest 10%. Year is 1 year. So simple interest formula, P into R into T, divide by 100. So 15,000 into 10 into 1 divided by 100. I am getting 1500 rupees as the interest amount. So simple interest is 1500. And how much he will have to pay back to the bank? He'll have to pay back the principal plus the simple interest amount. So 15,000 plus 1500. 16,500 he has to pay back to the bank. Okay. Next question. Ankur borrowed 1 lakh for 3 years at the rate of interest of 4.5% per annum. Find the interest accumulated at the end of 3 years. Same thing. P into R into T upon 100. So 1 lakh into 4.5 into 3 upon 100. So these two zeros will get cancelled. So 1000 into 4.5 into 3, when you will solve, you will get 13,500. Okay. So you have to do the basic multiplication. Okay. basic multiplication. 1000 when you will do it into 4.5. Okay, 3 zeros, no? So 1, 2 and 3. This will become 4500 into 3. It will become 13,500. These are simple basic calculations which you all should know. Find out the difference between compound interest on 5 lakhs for 1 year at 9% per annum, compounded quarterly and compounded half yearly. Two different things. One, it is getting compounded every quarter. Every quarter that interest amount is getting back added, and then again interest is getting calculated. And one is half yearly. Okay, the time period is 1 year and rate of interest is 9%. They have given you also compounded interest half yearly is it is compounded interest. If for half yearly it is 5460123. Okay, and compounded interest for quarterly it is not 23, it is 5460123. This 3 is not there, huh? I'm sorry. Okay, minus 541. Okay, this is larger number, so subtract the smaller from the greater number. You are going to get the answer as 529. So see, imagine if you are going to do the interest compounding quarterly, you are going to get 529 rupees more. Okay. Now, yeah. So this is it with the interest related questions. Okay, simple interest and compounded interest, both you have to just apply the formula and find the answer. Okay, so generally they are not going to give you for more number of years. It will always be maximum 2 or 3, so that you know when you are doing the compounding also, it is easy for you all to solve manually. So this is it with the interest, simple interest and compound interest. Okay everyone, so now we are just left with the next part, which is profit and loss. See you all. Bye.